Hi, good evening, everyone. So, beta, today I am going to go ahead and do section 5.3 of Devore, and we are going to cover this entire section today. Take care, let's start. So, first of all, we want to go ahead and we want to understand what is statistics. Now, statistics is basically a science of understanding sample from population. देखो, बट नॉट ऑलवेज द पॉपुलेशन विल बी एट डिस्पोजल. बहुत बारी ऐसा होगा कि आपको पॉपुलेशन के बारे में सारी इंफॉर्मेशन नहीं होगी, राइट? सो वेन एवर योर पॉपुलेशन विल नॉट बी एट योर डिस्पोजल, जब भी आपको पूरी पॉपुलेशन ना पता हो, then a sample will help you gain relevant information from the population. For example, the easiest example can be, let's say I want to know that how are my students performing in mock test, and I don't have the data of all the students, because maybe I have 1,000 students but only 30 students gave the test. Remaining people did not give the test. They did not give the mock test, and I want to get some estimate that how will they perform in the final exam and how they are performing. So in order to go ahead and in order to understand how will the students perform based on the performance of the mock test, what will I do? I will collect the data of this sample, and from this sample I will try to understand कि ठीक है इन 30 बच्चों में किसके marks कितने कितने आए हैं. Based on that, then I will go ahead and I will establish a result कि ठीक है अगर इन बच्चों के इतने इतने मार्क्स आए हैं तो पूरी पॉपुलेशन के इतने नंबर तो आ जाएंगे, ऐसा बच्चा परफॉर्म करेगा, राइट? So whenever you go ahead and you want to understand something about the population based on the sample के basis पे आप population के बारे में कुछ जानना चाहते हो, then that is called as statistics. वो अपने आप में stat की definition है. So statistics is the science of understanding sample from given population. ठीक है, क्यों ऐसा करना पड़ता है, क्यों हमें सैंपल के साथ काम करना पड़ता है? सो वी नीड टू वर्क विद द सैंपल बिकॉज नॉट ऑलवेज द पॉपुलेशन विल बी एट योर डिस्पोजल, द पॉपुलेशन विल बी एट योर हैंड. आपके पास हमेशा पॉपुलेशन होगी ही नहीं काम करने के लिए, सो यू विल हैव टू वर्क विद द सैंपल. So sample can be used to understand something about the population. Like for example, bache, I always give this example. What happens during the time of elections? Now, during election, we are not aware about what happens and which party will win. Party A जीतेगी या party B जीतेगी. So during that period of time, what will we go ahead and we will do? We will ask some people कि अच्छा आपने party A के लिए vote किया या party B के लिए vote किया. And based on what people will tell me, then I will gain some information कि अच्छा ठीक है party A जीत सकती है, party B जीत सकती है. So we will go ahead and we will use the sample to understand more information about the population. ठीक है. Now let us go ahead and let us try to consider an example. So for this example, what I have done is I have taken 10 data points. एक population है जिसमें 10 number हैं 1, 2, 3 till 10. And I am asking you to go ahead and collect a sample, and this sample basically is having 2 observation. So out of 10, I am saying to create a sample और उसमें 2 observation होनी चाहिए. It should have 2 observations with it. So what will you go ahead and do? Beta, you can create sample in multiple ways. आप बोल सकते हो कि out of this population from 1 to 10, my sample 1, suppose there are different students. तो मैंने student 1 को बोला कि okay, tell me what the sample will be. और student 1 ने out of these 10 observation number 2 and observation number 5 को choose किया. Maybe student number 2, that student went ahead and chose observation number 3 and observation number 7. तो basically different students can choose different observation. मैंने उन्हें बोला है कि पूरा population में से choose 2 observation. They can go ahead and they can choose any 2 observations. So therefore, what will happen is this will become a random process in itself. क्यों random हो गया? Because out of the 10 observations that I am giving you in a sample, I am asking you to go ahead and choose any 2 observation, and hence the randomization will be involved. Now, suppose beta, I ask you a very basic question that in how many ways can you do this? So you will tell me, ma'am, this is very simple. We have 10 observations in the population, and out of these 10 observation, I need to choose 2 observation to form a sample. So this can be done in 10C2 ways. इतने samples इसमें से हम create कर सकते हैं. So this will give me 10 factorial by 2 factorial, 8 factorial. So 10 into 9 into 8 factorial by 2 into 8 factorial. So 8 and 8 will get cancelled and 45 samples can be created. So you will tell me ki ma'am, out of these 10 observations na, we can create 45 samples without repeating. Okay. So anyways, now coming forward beta. So what we have understood therefore is that going ahead and collecting a sample, that is an uncertain process. उसमें थोड़ी uncertainty involved है क्योंकि कोई भी 2 number आप sample में collect कर सकते हो. Now I just want to focus a bit on the technical words here. So beta, whenever we write capital X1 and capital X2, this actually goes ahead and represents the observation. तो जैसे अगर मैंने आपको बोला कि okay, there is a sample, there is a population, and this population, it goes ahead and it contains n observations, right beta? तो ये जो हमारी observations हैं, these are represented by x1 and x2, right? So I have x1, x2 and so on till xn. Now what you will do, out of these n observations, आपने कोई 2 observations लेके उसका sample बना दिया, right? Now the value of these observations, तो जैसे अगर मैंने आपको बोला कि ठीक है मैम, I told you कि out of these n observation, create a sample of 2 observation. तो आपने क्या किया? You tell me that look ma'am, I am choosing the observation number 2 and I am choosing observation number 10. मैंने बोला okay. Then I ask you what is the value? So you tell me ma'am, observation number 2 का जो value है वो small x1 है and observation number 10 का जो value है वो small x10 है. So the value that you get from there, that is denoted by small alphabets x1 and x2. So small alphabets basically represent the value and capital alphabets basically represent the observation. Clear हुई ये बात? So we can go ahead and we can say that capital X's represent the observation and small x's represent the sample value. Okay, now going one step ahead. Now, we need to understand that whatever task you will perform on the sample, but that will also be a random task in nature. Mane, just try to understand this thing. But I have this population. इस population में बहुत सारे numbers हैं. So it has number 8, 7, 1, 2, 5, 4, 3. ऐसे करके 10 numbers हैं, हाँ? I asked you, okay, from this population create a sample. तो आपने मुझे 2 numbers sample के create करके दे दिए. So you said, okay ma'am, we have collected the sample S1 और ये जो sample है ना, it consists of observation 4 and 2. Then I asked student number 2, beta go ahead and create a sample. So student number 2 created a sample and he collected number 5 and 3. So different students have collected different sample. यहाँ पे जो numbers आएंगे, it will absolutely be random in nature. आपको कुछ और मिलेगा, मुझे कुछ और मिलेगा. So there will be random numbers that will be collected. So it is a random process. These are random variables. अच्छा अब देखो बेटा, अगर मैं student 1 को बोलूं कि whatever sample you have collected ना, find the mean of that sample. So what will be the mean? 4 plus 2 by 2, 6 by 2, that means 3. And if I ask student number 2 कि बेटा okay, find the mean of your sample, so what will be the mean? So it will be 5 plus 3 by 2, that means 8 by 2, that means 4. So different students जो उनको mean value मिलेगी अपने sample की, that mean will also be different because the sample that they chose was different. So if I can say that the sample is a random thing, it's a random variable, it is random in nature, तो उस पे हम कोई भी process अगर करते हैं, we try to find out its mean, median, mode, variance, whatever process we do on that sample, it automatically becomes random in nature. वो अपने आप से random हो गया. क्यों random हो गया nature में बेटा? क्योंकि वो sample ही random था. जो आपकी वैल्यू आई वो अलग थी, जो मेरी आई वो अलग थी. इट वॉज अ रैंडम नेचर सैंपल. So if sample was random in nature, then whatever process will be conducted on that sample will also become random in nature. वो भी random हो जाएगा, right? Okay, so this is what it says. Any task performed on the sample will also be a random variable. ठीक है बेटा, कुछ कुछ वैल्यूज हैं जिसपे मुझे आपको ध्यान दिलवाना है यहाँ पर. सो ट्राई टू अंडरस्टैंड that whenever we talk about population versus sample, the mean of the population is called as mu, and the mean of the sample becomes x bar. Similarly, the variance of the population, that is called as sigma square, and the variance of sample is called as s square. The standard deviation of the population is sigma, and the standard deviation of the sample is S, right? So these are some of the important abbreviations that you have to remember. ठीक है बेटा. Now this is a table given in your book, table 5.1. Let us try to understand this table a bit. थोड़ा समझो यहाँ पर. तो यहाँ पर क्या किया है ना, उन्होंने बोला कि assume करो कि एक population है और उसका डिस्ट्रीब्यूशन उन्होंने एज्यूम कर लिया दैट इट इज वीबुल डिस्ट्रीब्यूटेड. इस वर्ड पे इतना ज्यादा ध्यान नहीं देने की जरूरत है. जैसे एक्सपोनेंशियल डिस्ट्रीब्यूशन होता है, नॉर्मल डिस्ट्रीब्यूशन होता है, बाइनोमियल होता है, वैसे ही वीबुल डिस्ट्रीब्यूशन होता है. हमें उससे कोई मतलब नहीं है. वी आर नॉट कंसर्न विद इट. उन्होंने यहाँ से जो पॉइंट रखना है, हमें उससे उस पॉइंट को ही हाईलाइट करना है. सो देर इज अ पॉपुलेशन बेटा, देर इज अ पॉपुलेशन इन हैंड, और उस पॉपुलेशन से हमने एक सैंपल क्रिएट किया है. हाँ, अब ये सैंपल का हमें यहाँ पे डेटा दिया हुआ है. एंड द पॉइंट इज कि आप ऐसा एज्यूम कर सकते हो दैट देयर हैव बीन 6 डिफरेंट स्टूडेंट्स. तो ये सैंपल स्टूडेंट 1 ने कलेक्ट किया, ये सैंपल स्टूडेंट 2 ने कलेक्ट किया, ये सैंपल स्टूडेंट 3 ने, स्टूडेंट 4 ने, स्टूडेंट 5 ने और स्टूडेंट 6 ने. सो ये अलग अलग सैंपल्स क्रिएट किए गए हैं, एंड दीज आर बीइंग क्रिएटेड बाय डिफरेंट स्टूडेंट्स. Now what you have to understand is कि हर सैंपल को जो साइज है that is 10. So the sample size is 10. So if you notice this is sample number 1. इसको assume कर लो student 1 ने ये sample create किया है. So these are the 10 observations of this sample number 1. Like that you have sample number 2. हाँ बेटा. And these are the 10 observations. अगर student 2 अपना sample create करेगा तो वो ये observation रखेगा. Now what you have to notice here is that these observations they differ. तो जो student 1 का observation रहेंगे, they will be very different from student 2's observation, and in that sense we can go ahead and say that collecting sample is a random process. क्योंकि हर एक का observation differ कर रहा है, so we can go ahead and we can say that collecting sample is a random process. Now here is the sample mean given to you. And then you're also given the sample median, and you're also given the sample standard deviation. ये 3 चीजें इस आपको टेबल में given है. Now if you just note down the sample mean, you will notice that the sample mean also differs. तो अगर आप पहला नोटिस करो, इसका sample mean 4.40 है, whereas this sample mean is 4.1, this is 3.6, 5.7. So not only each sample is different, but also the sample mean that is collected, that is also very, very different. So we can say that yes, collecting sample is a random process. The data points of the sample are random in nature, but not only that, the sample mean is also random in nature, right? The sample mean is also random in nature. ऐसे आप देखो कि sample mode का भी जो अलग-अलग sample के mode आ रहे हैं, they are also very, very different. And therefore we can say that this is also a random variable. That's also a random variable, and same is the case with sample standard deviation. तो हम ये बोल सकते हैं that ultimately not only sample values differ from one student to another, ना ही सिर्फ sample random values से बना हुआ है, but sample का जो mean आ रहा है, mode आ रहा है, standard deviation आ रहा है, वो भी अपने आप में randomized हैं. They are also random in nature. और एक बहुत important point है, तो just try to understand बेटा that the book says कि ये जो हमने distribution, जो हमारी ये डिस्ट्रीब्यूशन थी जिससे हमने ये सैंपल कलेक्ट किया, सपोज उस डिस्ट्रीब्यूशन का जो मीन है वो 4.4311 है. The mean of that distribution is 4.4311. So what the book suggests is that if you will notice, तो किसी भी सैंपल का मीन 4.4311 नहीं है. It will be very close to population mean. ऐसा नहीं है कि अगर population mean 4.43 है तो सैंपल मीन 100 हो जाएगा. This will not be possible. हाँ, सैंपल मीन will be very close to the population mean. Nevertheless, यहाँ पे एक important point ये आता है जो हमें समझना पड़ेगा, that sample mean and population mean are not the same thing. तो अगर मैं sample mean निकालूं और population mean निकालूं, ये दोनों equal नहीं होंगे. They will not be equal to each other. So just go ahead and see here. Here the sample mean is 4.40, 5.92, 4.42, 4.1, 3.6 and 5.7. So we can clearly see that the sample means are not the same. They are different values. Sample के जो mean आ रहे हैं वो population mean के equal नहीं आ रहे हैं. They are different from the population mean. Right? Okay, beta. Now let's look into these 3 points that I have written. First of all, मैंने आपको बता दिया कि इस example में we are taking 6 samples, हर एक का size 10 है. And I have shown to you that each sample has a different mean. And I have shown you that each observation and sample mean are random in nature. तो ना ही सिर्फ सैंपल की ऑब्जर्वेशन रैंडमली आ रही हैं, बट सैंपल का जो मीन है वो भी रैंडम इन नेचर है. दैट इज ऑल्सो रैंडम इन नेचर. क्लियर? ठीक है बेटा. नाउ बेटा, दीज वेरिएबल्स, दीज आर कॉल्ड एज स्टैटिस्टिक्स. स्टैटिस्टिक्स क्या होता है? या एक्चुअली नॉट स्टैटिस्टिक्स, स्टैटिस्टिक बिना एस के, स्टैटिस्टिक. सो स्टैटिस्टिक बेसिकली कोई भी ऐसी चीज है जो हमें पॉपुलेशन के बारे में कोई भी इंफॉर्मेशन दे रही है. इट इज गिविंग अस इंफॉर्मेशन अबाउट द पॉपुलेशन और अपने आप में वो रैंडम इन नेचर है. और क्योंकि कोई भी चीज जो रैंडम है उसका प्रोबेबिलिटी डिस्ट्रीब्यूशन होगा, तो स्टैटिस्टिक का भी एक प्रोबेबिलिटी डिस्ट्रीब्यूशन अटैच्ड होगा. फॉर एग्जाम्पल बेटा, एक रैंडम वेरिएबल का एग्जाम्पल हो सकता है द नंबर ऑफ टाइम्स दैट आई टॉस अ कॉइन एंड गेट हेड. ठीक है, सपोज मैंने बोला कि मैं 2 टाइम्स एक कॉइन को टॉस कर रही हूं एंड आई एम इंटरेस्टेड इन अंडरस्टैंडिंग हाउ मेनी हेड्स आई हैव गॉट. तो बेटा अगर मैं देखूं तो मेरा सैंपल स्पेस हो जाएगा हेड हेड, हेड टेल, टेल हेड, टेल टेल. एंड इसमें ये बात बहुत क्लियर है दैट द नंबर ऑफ हेड्स दैट आई कैन गेट, इट कैन बी ईदर 0 और इट कैन बी 1 और इट कैन बी 2. एंड इसके कॉरेस्पॉन्डिंग हमारे पास प्रोबेबिलिटी आ जाता है दैट 0 हेड्स का प्रोबेबिलिटी इट अकर्स 1 out of 4 times, 1 head probability it occurs 2 out of 4 times, and 2 head probability it occurs 1 out of 4 times. So any variable which is random in nature has an associated probability distribution with it. उसका एक associated probability distribution होता है, right? So same is the case here बच्चे. तो हमने क्या बोल दिया? We have said कि जो हमारा sample mean आया है ये एक रैंडम वेरिएबल है क्योंकि ये सैंपल टू सैंपल डिफर कर रहा है. सो इट इज अ रैंडम वेरिएबल. एंड क्योंकि ये एक रैंडम वेरिएबल है, देयरफॉर इसका अपने आप में कोई प्रोबेबिलिटी डिस्ट्रीब्यूशन रहा होगा. मतलब क्या हो गया? दैट इफ आई हैव दिस पॉपुलेशन, हाँ, और इससे हर स्टूडेंट ने एक सैंपल मीन निकाला, स्टूडेंट 1, स्टूडेंट 2, स्टूडेंट 3, हर एक ने एक एक सैंपल बनाया और इसका इन्होंने सैंपल मीन निकाला. तो इट मे बी पॉसिबल कि शायद फर्स्ट सैंपल मीन 10 आया हो, दूसरा सैंपल मीन 5 आया हो, फिर 4 आया हो, फिर वापस 10 आया हो, एंड सो फोर्थ. तो ये रैंडमली आ रहे हैं सैंपल मीन डिपेंडिंग ऑन कि हमने कौन सी 2 ऑब्जर्वेशन चूज की होंगी टू फॉर्मुलेट द सैंपल. नाउ द इम्पोर्टेंट पार्ट हियर इज दैट इफ आई गो अहेड एंड आई क्रिएट दिस सैंपल मीन कि what have been the values and what have been their corresponding probability, then that will be a probability distribution. Like for example, I can say that okay, 10 sample mean 10 has occurred in 5 out of 25 samples. Sample mean 5 has occurred in 3 out of 25 samples. तो ये जो sample mean है, we can go ahead and create a probability distribution of the sample mean, and therefore we can go ahead and say that okay, ये अपने आप में रैंडम इन नेचर है एंड इट विल हैव एन एसोसिएटेड प्रोबेबिलिटी डिस्ट्रीब्यूशन अटैच्ड. ये बात क्लियर हो गई? ओके. नाउ क्योंकि सैंपल मीन जो है दिस इज गोइंग टू गिव अस सम इंफॉर्मेशन अबाउट द पॉपुलेशन मीन. It is going to help us understand more about the population mean. So we can go ahead and we can say that it is called a statistic. तो एक statistic क्या क्या है बच्चे? What is a statistic? ध्यान से समझने की कोशिश करो statistic को. A statistic is anything which is a random variable. Because it is random in nature, उसकी एक अपनी probability distribution रही होगी. It will have an attached probability distribution with it. And this is helping me gain more information about the population. तो जैसे यहां पर मुझे x बार हेल्प कर रहा है ये पता करने में कि पॉपुलेशन का मीन क्या रहा होगा. यूजिंग दीज x बार, यूजिंग दीज सैंपल मीन्स I can get some information about the population mean. I will tell you how to get that information. वो मैं अभी आपको थोड़ी देर में बताऊंगी. But I can go ahead and I can get some information about the population mean based on the sample mean. So this is now therefore a statistic. इसको हम क्या बोल देंगे? We will call this as a statistic. Am I clear with this part? ठीक है बेटा. Now let's go ahead and read this out. अब एक बात आती है जिसे बोला जाता है पॉइंट एस्टिमेट. तो इस पे हम थोड़ी बात और करेंगे इन द कमिंग क्लासेस. वी विल टॉक मोर अबाउट दिस. बट देयर इज समथिंग व्हिच इज नोन एज अ पॉइंट एस्टिमेट. राइट बेटा पॉइंट एस्टिमेट मतलब एक नंबर. वन पॉइंट मीन्स क्या होता है? डॉट. वन नंबर. सो एनीथिंग व्हिच इज अ पॉइंट एस्टिमेट इज अ सिंगल नंबर which is helping you understand more about the population. तो अगर कोई एक सिंगल नंबर मेरे को मेरी पॉपुलेशन को ज्यादा समझने में हेल्प करता है then that becomes a point estimate. So in this case, because the mean of the sample is helping me understand more about the mean of the population, so I can go ahead and call this as a point estimate. इसको मैं point estimate बोल सकती हूँ. Right? So if a single number, जैसे अगर मैं बोलूं variance of sample helps me understand more about the variance of the population. The standard deviation of the sample helps me understand more about the standard deviation of the population. So if a single thing helps you understand more about the population, then we can go ahead and say कि it will be called as a point statistic. उसको हम एक point statistic बोल देंगे. The sample mean gives information about the population mean. ठीक है बच्चे, this is a definition given in the book. इसको एक बारी हम read कर लेते हैं. Let's read this out. A statistic is any quantity whose value can be calculated from sample data. तो सबसे पहली बात ये है कि how do we calculate the statistic? We calculate the statistic based on the sample data. Right? Second, prior to obtaining data, there is uncertainty as to what the value of any particular statistic will be. तो ये बात समझने वाली है कि क्योंकि मुझे यही नहीं पता कि मेरा सैंपल क्या बनेगा. राइट? फॉर एग्जाम्पल इन द एग्जाम्पल आई हैव गिवन यू. ठीक है, जैसे अगर हम इस टेबल पे वापस आ जाएं, इफ आई जस्ट लुक बैक इनटू दिस टेबल, तो बेटा इफ माय सैंपल इज दिस, अगर मेरा सैंपल ये बनता है तो मीन की वैल्यू ये होगी. बट अगर मेरा सैंपल ये बनता है तो मीन की वैल्यू ये होगी ना. तो मैं मीन के बारे में तब तक नहीं बोल सकती. आई कैन नॉट टेल अबाउट द मीन टिल दैट पॉइंट, till the point I don't know what my sample is. तो हमेशा एक uncertainty रहेगी statistic में, because statistic is going to be a function of what has been collected in the sample. आपने sample में किस चीज से related information collect की है, उस पर depend करेगा कि statistic का value क्या आएगा. What will be the value of the statistic, right? Therefore, a statistic is a random variable. तो book clearly specifies that a statistic will be a random variable and will denoted by an uppercase letter. तो हम random variable को हमेशा capital letter से represent करते हैं. A lowercase letter used to represent the calculated value. तो इसकी जो observation की values आती हैं, they are represented by lowercase, और random variable itself is represented by a capital uppercase. Right? I hope this is clear to everyone. ठीक है बेटा. This I have explained. Okay. Now, the question is how do we go ahead and create a sample? एक sample को हम कैसे create कर सकते हैं? So we can go ahead and we can create a sample either with replacement or without replacement. बेटा try to understand. With replacement का मतलब ये हो गया कि सपोज आई टेल यू दैट देयर इज अ पॉपुलेशन फ्रॉम 1 to till 10, और मैंने स्टूडेंट 1 को बोला कि कोई भी दो नंबर निकालो एंड ही प्लग्स द नंबर 2 and 7 या 2 and 5 से, तो ये दो नंबर्स को या ये दो चिट्स को मैंने इसके अंदर वापस डाल दिया. आई अगेन हैव 10 चिट, और फिर मैंने स्टूडेंट 2 को बोला कि पिक अप एनी टू नंबर्स. सो विद रिप्लेसमेंट का मतलब ये हो जाता है दैट आई एम पुटिंग दैट सैंपल बैक. जैसे इफ आई टेल यू कि ये इंडिया है और यहाँ पर बहुत सारे सिटीजन्स हैं, और मैंने किसी एक सिटीजन को पकड़ के सर्वे कर लिया, तो मैंने उस सिटीजन को वापस इसमें ही डाल दिया, और वापस मेरे पास वही सेम ऑब्जर्वेशंस हैं जिसमें से मैंने दोबारा किसी सिटीजन को पिक किया. सो देयर इज अ चांस कि शायद यही सिटीजन आप दोबारा भी पिक कर सकते हो, बिकॉज ही विल अगेन बी पार्ट ऑफ योर पॉपुलेशन फ्रॉम वेयर यू आर पिकिंग. तो दैट बिकम्स विद रिप्लेसमेंट. ऑन द अदर हैंड विदाउट रिप्लेसमेंट मीन्स आप रिप्लेस नहीं कर रहे हो. सो इफ यू हैव गॉन अहेड एंड कलेक्ट, if you have taken this person और इसको आपने यूज किया to do the survey, then you will just take this person out. He is no more a part of your population. और next time जब आप अपना next survey करोगे, so this person will already be out. He will no more be a part of that, right? ठीक है, so that becomes without replacement. So with replacement में एक चीज ये समझने लायक होगी अब कि it is possible that you get the same value twice. जैसे for example, if I tell you that my population has number 1, 2, 3 till 10, and I ask you, beta, make a sample of 2 observation, तो it is possible कि आप दोनों ही observations को same ले लो. You can take both the observations to be the same observation. तो let's say कि आपने जो दो observation choose की होंगी, those 2 observation, they are 3. वो जब आपने पहली चूज की, इट गोज बैक इनटू द पॉपुलेशन, फिर से आपको चूज करनी है, और अगली बारी भी आपने 3 ही चूज कर लिया. सो इन दैट केस बेटा व्हाट विल बी द सैंपल मीन? योर सैंपल ओनली हैज 2 ऑब्जर्वेशन, और दोनों ही सेम है, क्योंकि जब आपने पहली चिट चूज की 3 की, उसके बाद आपने उस चिट को वापस उसी पॉपुलेशन में डाल दिया, एंड नेक्स्ट टाइम ऑल्सो यू चोज 3 ओनली. सो बेटा व्हाट विल बी द मीन नाउ? मीन विल बी 3 + 3/2, दैट मीन्स 6/2, दैट मीन्स 3. और अगर आपका मीन 3 हो गया, व्हाट विल बी द स्टैंडर्ड डिविएशन? स्टैंडर्ड डिविएशन इज समेशन xi minus x bar होल स्क्वायर डिवाइडेड बाय n minus 1. ठीक है, ये सैंपल का वेरिएंस होता है, राइट? सो यू कैन गो ahead and clearly see कि xi and x bar are the same only. And if xi and x bar are the same, तो इनका deviation would be 0. So this would actually be 0 square divided by n minus 1, that means 0. So what you understand from here, that in case that the sample is with replacement, there is a chance that you will go ahead and you will see both the values to be the same. And if both values will be the same, then in that case, the variance of the sample will turn out to be 0. जो आपका sample का variance है, वो 0 हो जाएगा. Am I clear with that part? Okay, beta. So now we need to understand कि because I am creating a sample और sample अपने आप में random है, तो there are 2 things which will formulate 2 conditions which will be required to formulate a random sample. Again beta, this is the next definition which has been used in the book. इस definition को थोड़ा सा पढ़ते हैं हम. The random variable x1, x2 till xn are said to form a random sample of size n if 2 things are satisfied. 2 चीजों का satisfy होना बहुत ही जरूरी है for us to call it as a random sample. अगर हमें sample को random sample बोलना है, तो 2 चीजें satisfied होनी चाहिए. The first thing that should be satisfied is that the xi's are independent random variable. तो हर बारी जब हम एक xi choose कर रहे हैं, तो उसको independent होना जरूरी है. उसको इस पे डिपेंड नहीं करना चाहिए कि पिछला xi क्या choose किया था. Which will happen in case of sample without replacement. It will happen in case of sample without replacement that they will be dependent on each other. Why beta? Let's take an example. So again, I am taking this population from 1 to 10, and I ask you, ठीक है बेटा, choose 2 values but without replacement. So without replacement का क्या मतलब हो गया? That suppose beta you create a sample and you choose the first value to be 3 So the second value cannot be 3. The second value will be any of these remaining 9 values, but it will not be 3. The second value of जो भी choose करोगे, it will be dependent on what first value you have chosen. Because it cannot be 3. आप 3 को दोबारा choose नहीं कर सकते हो. So in case of without replacement, you have to understand that it becomes dependent in nature. And if it becomes dependent in nature, then you need to understand that it will not be a independent random sample. And if it will not be an independent random sample, then it will not be a random sample at all. It will not be a random sample at all. So for it to be called as a random sample, if we need to call it as a random sample, ये बात बहुत ही important है for you to understand that we need that exercise should be independent in nature, and exercise will be independent in nature only and only when you have with replacement. Because in with replacement, I don't care what the last number was chosen. I can still choose any of the 10 numbers. मैं फिर भी अगली बार जाके दोबारा उन 10 में से कुछ भी choose कर सकती हूँ. I can go ahead and choose any of the 10 numbers. Am I clear with it? Okay, beta. The second thing is that every xi has the same probability distribution. So try to understand that all these samples that I'm collecting, they are coming ideally from the same population, right? And therefore, they must have the same population, same distribution, right? Same probability distribution, right? So this is the next thing, therefore, that whenever we talk about every xi, then these should have the same distribution. Now, if these two things are satisfied, that you have independent random variable and they have the same distribution, then such random variables, beta, they are known as IID. That means they are called as independent and identically distributed. Independent and identically distributed. So if these two properties are satisfied, then we can go ahead and say that it is independent and identically distributed. But ye baat important hai. This is very nicely written in the book, that I can go ahead and create an IID still if the sample size and population size ratio is less than equal to 0.5 and I have without replacement. तो अभी तक मैंने आपको ये बोला कि with replacement में ही सिर्फ independent create होगा, random variable independent सिर्फ with replacement में होगा, but in without replacement also I can go ahead and I can create. In without replacement also, I can go ahead and I can create IIDs, but ये property satisfied होनी चाहिए. So for example, if I tell you that the sample size is 5 and I tell you that the population size is 100, right? The population size is 100. So what is my n by n? It is going to be 5 divided by 100. That means it is going to be 0.05, clearly less than 0.5. So in this case, I will go ahead and say कि हाँ, although it is without replacement, but still I will be able to create IIDs. बहुत ही rare chance है कि ये जो 100 observation है, इसमें से जो हम 5 observation collect करेंगे without replacement में, they will be dependent on each other. So we will be able to create a independent sample. Am I clear with it? Okay, beta. So I will end this lecture here for today. And in the next lecture, we will continue with section 5.3 and we will try to end this with some questions. And we will be talking about deriving the sampling distribution. Okay, beta. Thank you. Hello, beta. Good evening, everyone. So, bache, in the last class, we had started with chapter 5.3 of Devore. And this is in your first unit of semester 2 stats part, and today I'm going to continue from there. So we have already studied what is a statistic, and we also talked about what are IIDs, what is independent and identically distributed variable. IID किसको बोलते हैं उसके बारे में भी हमने एक बारी बात की थी. Now I want to go ahead and I want to continue from here. So today I want to talk about deriving the sampling distribution. How can sample distribution be derived? So in order to derive the sampling distribution, there are two techniques that we have. The first one is known as probability rule. And the second one is known as the process of stimulation. Right, beta? So there are two ways in which we can go ahead and we can derive the sampling distribution. The first one is known as probability rules. And the second one that we have, that is known as stimulation. Okay, let us talk about the example first. तो ये बहुत interesting example है और actually on the basis of this example only there is a back question given. तो जो question number 37 है आपका after 5.3 part of Devore, that is actually based on this example only. तो ध्यान से हम इस example को एक बारी देखते हैं बच्चे. It says a certain brand of MP3 player in 3 configuration, a model with 2 GB of memory costing $80, 4 GB of memory priced at $100 and 8 GB version priced at $120. तो आपको 3 वर्जन दिए हुए हैं और उनके रिस्पेक्टिव प्राइसेस दिए हुए हैं कि आप या तो $80 अर्न कर सकते हो या 100 या फिर 120. 20% of the purchases are with 2 GB. तो आपको यहाँ पे percentage is given to you as 0.2. And then it says that 30% is with 4 GB. So you are given here 0.3. And then it goes ahead and says that 50% is with 8 GB. तो यहाँ पे आपको percentage दिया हुआ है बेटा 0.5. You are already given this information. ये आपको पहले ही दी हुई है. Right. अब ध्यान से देखो that this is the information given about the population. So in the last class, I had told you the difference between population versus sample. मैंने आपको इसका difference बताया था और मैंने आपको ये बात क्लियर बोली थी कि देखो population is a bigger thing and पूरा का पूरा population may not be at your disposal. बट इसी पॉपुलेशन में से वी पिकअप अ स्मॉलर डेटा सेट और उसको हम सैंपल बोल देते हैं और सैंपल के बेसिस पे हम पॉपुलेशन के लिए कुछ इन्फर करते हैं. सो वी ट्राई टू अंडरस्टैंड मोर अबाउट द पॉपुलेशन बेस्ड ऑन द सैंपल. ठीक है. नाउ ट्राई टू अंडरस्टैंड दैट दिस डेटा, द इंफॉर्मेशन दैट इज गिवन टू यू, जब भी आपको एक ऐसी जनरल इंफॉर्मेशन दी होगी, whenever you will be given a general information कि you know इस इतने वाले को मैं इतने पे सेल कर रहा हूँ, इतने वाले को इतने पे, so that general information will always be the information belonging to the population. So in this case, beta, what we can go ahead and see, it says then the probability distribution of cost of single MP3 player is given by this. तो यहाँ पे बहुत ध्यान से हमें देखना पड़ेगा बेटा. इट सेज म्यू का मतलब हो गया पॉपुलेशन मीन. सो यू आर गिवन दैट द पॉपुलेशन मीन इज 106. और थोड़ा सा अगर हम आगे बढ़ते हैं, सो इट सेज सिग्मा स्क्वायर इज 244. इसका मतलब ये हो गया बेटा दैट पॉपुलेशन वेरिएंस that is given to you as 244. तो आपको population mean and variance दिया हुआ है. Before I go further into the question, एक बारी हम देख लेते हैं how these values are actually derived. इन values को कैसे derive किया गया है, we need to understand that also. So बेटा population mean को निकालने के लिए it is nothing but the expected value of this x. So how can I find the expected value of x? I will do 80 into 0.2 plus 100 into 0.3 plus 120 into 0.5. 120 into 0.5. So if I just try to solve this, I will get 80 into 2 by 10 plus 100 into 3 by 10 plus 120 into 5 by 10. So what will I get here? This will be 16. This will be 30. And this will be 12 into 5. That means 60. So you get 90 plus 12, that means 106. And you can see that here the population mean is given as 106. तो ये जो 106 हम यहाँ पे देख रहे हैं, this value that I see here, this 106, actually this is very simple. ये आपका सिर्फ expected value है and the formula of expected value is nothing but summation x into px. And you can see that this is the expected value that you have in this case. Right, beta? Okay, beta. Now what I will go ahead and do now, we will focus on the second part. So look here that this says that the variance of the population is 244. Let us spend 1 minute and just quickly calculate the variance also. एक बारी variance भी निकाल लेते हैं. So in order to go ahead and in order to find the variance, so we know that the formula for variance is E of x square minus E of x whole square minus E of x whole square. So this is very, very simple. E of x square निकालने के लिए you need to do summation of x square into px. So E of x whole square. Right, beta? Achha, now if I just go to this part, if I just focus on this part, what will I realize? I will realize in this case that E of x square will be 80 square into 0.2 plus 100 square into 0.3 plus 120 square into 0.5. Right, beta? So quickly we will go ahead and we will calculate this. हमेशा ना book में जो भी लिखा है, you need to understand what is written and why it is written. उस पे एक understanding होना बहुत जरूरी है. Just don't skip the book. Book ही सबसे important है and you should understand each and everything written in the book. So if I just go ahead and I find out E of x square, what will I go ahead and get? So beta 80 into 80 into 0.2, this goes ahead and gives me 1280 plus 100 into 100, that is into 0.3. This gives me 3000 plus 120 into 120, that means 14400 into 0.5, that means it gives me 7200. Right, beta? So if I just add this together, so plus 3000 and plus 1280, this gives me 11,480. So I am just 480. So I'm just going to go ahead and just going to put this value here. So this will be 11,480 minus E of x whole square, that means 106 whole square. So if I just do 106 into 106, I will go ahead and get 11480 minus 11236. So minus 11480, and this will give me the answer as 244. So therefore, I can go ahead and say that the variance will be 244. ये वाला part clear हुआ, how mean and variance are given to you. अब हम एक next step पे चलते हैं. So now what happens is, it says that on a particular day, 2 MP3 players are sold. तो एक दिन में हम 2 MP3 players sell कर रहे हैं. Now you need to understand बेटा कि वो 2 MP3 player कुछ भी हो सकते हैं. दोनों ही MP3 player 2 GB के हो सकते हैं. Both the MP3 player can be of 4 GB. Both the MP3 player can be of 8 GB. So I can sell them in any permutation combination possible. और ये with replacement case है. Because you can have the case where both the MP3 players sold are the same. दोनों ही आपके 2 GB वाले sell हो गए. So I have to create all those cases here. So I am selling 2 MP3 player. So this is the first MP3 player sold. This is the second MP3 player sold. So if both the MP3 players sold, they are this one. They are this one. 2 GB. ये 2 GB वाला MP3 player था. This was 4 GB MP3 player and this was 8 GB MP3 player. So if both the MP3 players sold are 2 GB MP3 player, it means that my revenue will be 80. So this is what I have gone ahead and I have written here. Here I am writing the revenue as 80 and 80. Now if I go ahead and I tell you कि नहीं, this is not the case. Rather I am telling you that, you know, I am selling 1 2 GB and 1 4 GB. So it will be 80 100. So I have gone ahead and written all possible cases here. यहाँ पे हमने वो possible cases सारे के सारे लिए हैं कि एक 2 GB, एक 6 GB, 8 GB, then 100, 80, 100, 100, 100, 120, 120, 80, 120, 100, 120, 120. So all possible cases जो भी हो सकते थे, that you can go ahead and sell 1 2 GB and 1 8 GB. तो 80, 120 का combination बन गया. We have written that. Or you can sell both 8 GB. तो 120, 120 का combination बन गया. So that is it. So I have gone ahead and I have written all possible combinations here. Now, beta, how is this probability calculated? So in order to calculate this probability, this is simply the probability of x1, x2. ये joint probability है. But since these are independent events, choosing the first one is independent of choosing the second one. That is why in this case, this is simply equal to probability of x1 into probability of x2. हमने simply इन दोनों को multiply कर दिया. Why have I gone ahead and why have I multiplied simply? I have multiplied it directly because beta simply बात है that these are independent events. So you can go ahead and simply multiply them. ठीक है जी. तो this is what I have gone ahead and done in this case. तो अगर हम 80, 80 को देखते हैं बच्चे, so 80 का probability is 0.2. So 0.2 into 0.2, this will be 0.04. That is what is coming in the first case. So similarly, I have tried to fill this box. So अगर हम यहाँ देखें, this is going to be 0.04 and this is what is appearing here. This appears here. Similarly, the next one goes ahead and says 80 and 100. So, if I go ahead and take 80 ka probability is 0.2 and 100 ka probability is 0.3. So I will get 0.06. So if I go ahead and I see here, this is giving me 0.06. Now, in similar fashion, I have gone ahead and I have filled this entire column. Ye pura ka pura column is filled on that basis that you are picking up on the probability of the first one into the probability of the second one, and that is going ahead and giving you the joint probability, and I am able to multiply individual probabilities because these are independent events. So क्योंकि independent events है, I have been able to go ahead and multiply them together. Okay, beta. Now this says what is going to be, please understand, what is going to be the mean of your sample. What is going to be the mean of the sample? So the mean of the sample will be the first observation plus the second observation divided by 2. So if you can go ahead and see here, the first mean is coming as 80 because my first observation is 80 and second observation is also 80. So I can clearly go ahead and say that 80 plus 80 by 2 will give me 80. Now if I look into the second observation, which is 90, so it is nothing but 80 plus 100 divided by 2. So 80 plus 100 is 180. 180 divided by 2 is going to give me 90. And in similar fashion, I have gone ahead and filled this entire column. So देखो 80 plus 120 is 200 divided by 2 is 100. 100 plus 80 is 180 divided by 2 is 90. 100 plus 100 is 200 divided by 2 is 100. So in that way, I have been able to go ahead and find these mean values. So this column basically goes ahead and it represents the mean of the sample. Sample only had 2 data points और उनका मैंने mean निकाल के यहाँ पे लिख दिया है. Now let's talk about the variance of the sample. So what is the formula of the variance of the sample? Summation xi minus x bar whole square divided by n minus 1. Now in this case, beta, we know कि मेरा जो sample था ना, it only consisted of 2 observation. So this will be summation xi minus x bar whole square divided by 2 minus 1. So summation xi minus x bar whole square divided by 1. So this will be nothing but summation xi minus x bar whole square. So now if I go ahead and I look into the first row, पहली row को देखो, so this is going to be 80 minus 80 whole square plus 80 minus 80 whole square, that means 0. So you can clearly see that both the observations are simply the value of the mean. देखो यहाँ पर दोनों ही observation simply mean के बराबर ही आ रही हैं. So since both the observation are simply the value of the mean, the variance is going to be 0. तो यहाँ पे हमने variance को 0 कर दिया है. Now let us go ahead. So I'm going to just remove this from here. Now let us go ahead to the second one. This is done. Now let's look here. So their mean is 90, isn't it? So I will do for this one 80 minus 90 whole square plus 100 minus 90 whole square. So this is going to give me minus 10 whole square, which means 100, plus 10 whole square, which means 100. So this will be 200. So if you can go ahead and see in the second place, you can clearly see that this is coming as 200. Okay, beta, let's come to the third one. तो अब इस केस में हम देखेंगे, so what do we find out? We see 80 minus 100 whole square plus 120 minus 100 whole square. So 120 minus 100 whole square. So this will give me minus 20 square, that means 400, and 20 square, that means 400, so 800, that's this value. Again, beta, I am leaving it up to you. In similar fashion, you will be able to find all these variances. तो ये individual sample के variance हैं. So we have been able to go ahead and find the mean of the individual sample, and we have also been able to find the variance of the individual sample. So we have been able to fill these two columns. Up, most important thing, but we want to talk about these distributions. So up, because in the last class, I explained to you that sample mean is a random variable. So you need to understand that any random variable is associated with a probability distribution. And in order to understand the probability distribution of the random sample, हमें क्या करना होगा ना? We would need its frequency distribution. We would need its frequency distribution. So rather than directly focusing on this part, what I'm going to go ahead and I'm going to do is, I am going to find out कि कौन से जो x's हैं, x bar है, उनका क्या क्या value आ रहा है. What are the values that I can see here? Okay, so just I'm going to minimize this for a moment. So this is the table that we have created. And just focus on sample mean for now. अभी के लिए सिर्फ sample mean पे focus करो. Okay, so look that I want to focus on sample mean being 80. तो बच्चे, where all do you see the value 80? यहाँ पे दिख रहा है 80. Do you see anywhere else the value coming 80? No, we don't. तो इसका जो frequency of x bar रहेगा, that will be 1. Now let us focus on the mean value being 90. So where all do you see beta the mean value being 90? So here we see that the mean value is 90. Here I see that the mean value is 90. So two places. So frequency will be 2. Now beta, I go ahead and I focus on the mean value being 100. So where all do you see the mean value being 100? Here I see that the mean value is 100. Here I see that the mean value is 100. Here I see that the mean value is 100. So its frequency is 3. Then I want to say that mean value is 110. So where all do you see that the mean value is 110? But here I see the mean value is 110. Here I see that the mean value is 110. So 2. And at last, we see that the mean value is 120 and its frequency is 1. Now, you need to multiply this frequency with the corresponding probabilities. So what has been the probability of 80 beta? The probability of 80 has been 0.04. What has been the probability of 90 beta? The probability of 90 has been 0.06. What has been the probability of 100 beta? It has been 0.10. What has been the probability of 110 beta? It has been 0.15. And what has been the probability of 120 beta? It has been 0.25. Am I clear with it? Okay, beta. Now what you will do now, you will go ahead and multiply the frequency with the probability. You will go ahead and multiply the frequency with the probability. So this will remain 0.04. This will become 0.12. This will become 0.30. This will become 0.30. And this will go ahead and become 0.25. Right? This is what you will be going ahead and getting. Now what you get here, so you are going to go ahead and you're going to look into these. So 3, 4, 5, 6, 7, 8 and 9. And we had 10 observations, right? We had 9 only. Okay. So what you will be doing is now you will be just picking up on these x bars and you will be looking into these probabilities and you will be just going ahead and writing it here. Right? So you will be going ahead and you will be just writing them here. Am I clear with it? So look that for 100. Oh. So here is what the issue is beta. Note that for 100, we have jotted a wrong probability by multiplying. The reason is that for 100, the probabilities are not the same that I can simply multiply. You notice that here for 100, the probability is 0.10, and here it is 0.90, and again here it is 0.10. It is not the case in any other case, but only for 100, it is like this. So, just directly multiplying with 3 will give me wrong answer because one of the probability differs to 0.9. So what I will do better, therefore, because this may seem confusing, so you may simply add the probability because I see a difference in the probability of 100 here, right? So for 80, it remains at 0.04. For 90, I see 0.06 here and 0.06 here. So it was same as multiplying it with 2, so 0.12. The issue is with 100. With 100, I see 0.10, but I see 0.09 here, and then again 0.10. So this gives me the answer as 0.29. For 110, it's the same. I see the same number twice. So multiplying or adding gives me the same answer, 0.30, and here I get 0.25. So better add than multiply because we see a difference in the probability in this case. So you have been able to go ahead and you have been able to create this probability distribution table now. So this is what is reflected here. ये आपका probability distribution of X बन गया. Similarly, I want you to make a probability distribution of the variance. Variance का भी probability distribution बन सकता है. So in that case, what will we do? Let's start with the probability distribution of variance, beta. So what are the values that variance takes? It takes the value 0. What is the probability associated with it? So for 0, corresponding 0 here, I see 0.04. For 0 here, I will see 0.09. And for 0 here, I will see 0.25. Right? Then you go ahead and you look at the next variance, and the next variance comes out as 200. So for 200, I go ahead and I see 0.06. And then I see 0.06. And I see 0.15. And I see 0.15. Right? And then I just go ahead and I write the third value, which is 800. So for 800, I see 0.10. And then I see 0.10. Right, beta? So if I just go ahead and I sum this up, so यहाँ पे I will go ahead and get 13 plus 25. So 0.38. This will give me 0.20. And this will give you 30 plus 12, 0.4. Always remember, whenever you will go ahead and add these together, this should give you the answer as 1. Always. And the sum of the probabilities should be 1. So what we note down here is that this is the probability distribution of the variance that we have got. Again, beta, I want to point this out that we are talking about the sample variance. And because sample itself is a random variable, so in the last class we had studied that whenever you're working with a random variable and you do something on the random variable, मतलब आप random variable का mean, median, mode कुछ भी निकालते हो, that also remains as a random variable. वो भी एक random variable ही रहता है. Right? So since the variance of the sample is also a random variable, क्योंकि ये भी एक random variable है, therefore there will be an associated probability distribution with it. उसके corresponding हम एक probability distribution बना पा रहे हैं. Now, what we can go ahead and do, therefore, beta, we can also just plot this, right? Because this is a probability distribution, I may very well want to go ahead and plot this. So for the mean, I can go ahead and say that, okay, for value 80, its probability is 0.04, and for 90, its value is 0.12, and for 100, its value is 0.29, and so on and so forth. So this is what the book has gone ahead and done. For different values, the book has gone ahead and made a histogram. This histogram in particular, it refers to the histogram of the population. So if you go back to the population में we had only three values. कि the revenue can be 80, the revenue can be 100 and the revenue can be 120. और उनका corresponding probability दिया हुआ था 0.2, 0.3 and 0.5. But sample के mean if you notice it varies more. तो जब हमने sample में देखा तो we found that the mean can be 80. Welcome beta. The mean can be 80, the mean can be 90, it can be 100, 110 or 120. So what we note in the sample is that although the population could only take the values 80, 90 or 100, but we go ahead and we notice that in the sample, the mean can be anything from 80 to 120. This is an important point to make a note of it, right? Okay. Now, this is very, very important. Very important. Try to see this thing better. So, हमने क्या किया ना? हमने बोला we have a population at hand. The population had three things. Either my revenue could be 80 or 100 or 120. And we were given the corresponding probability 0.2, 0.3, 0.5. हमें population के बारे में पता था. And then we found out that the mean of the population is 106. Then we started making sample. So when we went ahead and we made the sample, जब हमने इसमें से sample बनाया, तो sample could have had any two observation. तो ऐसा हो सकता था कि इस सैंपल में दोनों ही जो हमारे वो आए, जो भी वॉट एवर मेमोरी कार्ड वी आर टॉकिंग अबाउट, उनका जो स्पेस है वो 80 GB वाला था. सो वी 2 GB वाला था. सो वी मेक अ रेवेन्यू ऑफ 80 ईच. एंड ये दो ऑब्जर्वेशन 80,100 भी हो सकते थे, ये दो ऑब्जर्वेशन 80,120 भी हो सकते थे. दे कुड हैव बीन एनीथिंग. सो ऑन दैट बेसिस ऑफ कोर्स वी वेंट अहेड एंड वी क्रिएटेड ऑल पॉसिबल सैंपल्स. हर सैंपल का हमने मीन निकाला. दीज वर द मीन ऑफ द सैंपल. नाउ लिसन टू मी वेरी वेरी केयरफुली. बहुत ध्यान से सुनो. इफ आई फाइंड द मीन ऑफ दीज मीन्स, जो भी हमने ये सैंपल के मीन निकाले हैं, वॉट एवर मीन वी हैव फाउंड आउट, अगर इनका ही हम दोबारा से मीन निकालें, इफ वी फाइंड आउट द मीन ऑफ दैट, मतलब क्या होगा बच्चे? मीन ऑफ मीन, व्हाट विल बी द एक्सपेक्टेड वैल्यू ऑफ मीन? इट विल बी 80. तो ये 80 वैल्यू आ रहा है मीन का, 90 आ रहा है, 100 आ रहा है, 80, 90 ये सब. सो इफ आई गो अहेड एंड आई फाइंड द मीन ऑफ दीज मीन्स, जो भी हमारे पास यहाँ पे वैल्यूज आई हैं, अगर मैं उनका मीन निकालूं, I will get it at exactly 106, which is the mean of the population. So this is a very important thing. Please make a note of it, that when we find the mean of the sample mean or expected value, when we find the mean or expected value of the sample mean, we get the value of population mean. हमें जो आंसर आता है, that is going to be the same as the population mean. हमें population mean ही मिल जाएगा. So try to understand बेटा. How do you find expected value? एक बारी मुझे बात बताओ, कैसे निकलती है expected value? It is summation. जिस भी चीज का expected value निकालना है, multiplied with its probability. तो हमें मीन की expected value निकालनी है, तो मीन की हमने probability distribution तो पहले ही बना लिया है. हमने सारे मीन लिख लिए, and corresponding to that we have written their corresponding probabilities also. So we have already written these means and their probability distributions. तो अगर मुझे इन मीन का मीन निकालना है, if I need to find the expected value of these mean, तो क्या करेंगे बेटा? 80 into 0.04 plus 90 into 0.12 plus 100 into 0.29 plus 110 into 0.3 plus 120 into 0.25. And when you will solve this, आपको realize होगा कि यहां से जो आपको value मिल रही है, the value that you are getting is exactly the mean of the population. आपको इसको solve करके exactly 106 ही मिलेगा. And this is a back question. जब आप exercise के questions में जाओगे, a very similar question is in the exercise, जिसमें आपको यही करना होगा. तो आपको क्या दिया होगा? You will be given a population. उससे आपको एक्सरसाइज में बोला गया है कि यू हैव टू क्रिएट अ सैंपल. इन सैंपल के जो मीन है उनका आपको प्रोबेबिलिटी डिस्ट्रीब्यूशन बनाना है और उससे सैंपल का मीन निकालना है, मीन ऑफ मीन, एक्सपेक्टेड वैल्यू ऑफ मीन निकालना है. एंड यू नीड टू शो कि वो पॉपुलेशन के मीन के इक्वल है. And this is exactly what we have done right now. So same example is there in the final exercise. Please do that example as homework. सब लोग वो example करेंगे ही करेंगे. Okay बेटा. अब हम क्या करते हैं ना? Let us try to find out the expected value of the variance. तो हमने ये sample variance का probability distribution यहाँ पे बनाया है. Right? हमने यहाँ पे इसका probability distribution create किया है. So if I ask you, beta, what will be the expected value of this? तो आप बोलोगे, and this is nothing but value multiplied with its probability. So 0 into 0.38 plus 200 into 0.42 plus 800 into 0.20. And when you will go ahead and you will solve this, so 200 into 0.42, this will give you the answer as 84. Plus this is 160, this will give you the answer as 244. और ये क्या था 244? This 244 was nothing but it was actually the variance of the population. It was nothing but the variance of the population. So अब हमने यहाँ से ये भी prove कर दिया है that the expected value of the variance of the sample will be equal to the variance of the population. The expected value of the variance of the sample is equal to the variance of the population. Again, beta, ये question back exercise में it is given to you and all of you will go ahead and try that question. ठीक है? Okay. So we have done this. ठीक है बेटा. So now you can go ahead and you can look into example 5.21. बहुत simple example है. In this example, वो क्या बोल रहे हैं ना कि let x1 represent the service time that it takes to serve customer 1 और x2 है service time to serve customer 2 and both of them they are exponentially distributed with the factor lambda. Both of them are exponentially distributed with the factor lambda and therefore जो total time होगा that will be x1 plus x2 that we will be having in this case. अब ये बोल रहे हैं what is the probability that both the customers will be served in some time. जैसे अगर मैं आपको बोल दूं कि किसी भी एक कस्टमर को सर्व करने के लिए मुझे x1 मिनट्स लगते हैं और किसी भी दूसरे कस्टमर को सर्व करने के लिए मुझे x2 मिनट्स लगते हैं, then what is the probability कि जो टोटल टाइम मुझे लग रहा है वो लेस देन इक्वल टू 10 मिनट्स है, right? So whenever you go ahead and you want to do something like this, so in a way, I need to find the CDF. CDF to less than equal to पे काम करता है. From the last semester, we know this. So beta, we need to go ahead and we need to find the probability that probability x1 plus x2 is less than equal to t. तो हमें ये निकालना है what is the probability x1 plus x2 is less than equal to t. ये चीज हम लोगों को यहाँ पर find करनी है. Now this is going to be the joint distribution क्योंकि x1 plus x2 है. So I need to go ahead and I need to work with the joint distribution. So this is what I am going ahead and doing here. This is going to be the joint distribution और इसको हम integrate कर रहे हैं. So if I just go ahead and I want to plot this thing somehow, तो इसको कैसे plot कर सकते हैं? तो I am going to take it with an equal to sign first. So x1 plus x2 is equal to t. So I am taking x1 here. I am taking x2 here. And क्योंकि x1 plus x2 equal to t है, so this will be a line like this. यहाँ पे भी t आएगा और यहाँ पे भी. Isn't it? You can always see this ना. So when you will go ahead and you will put x1 as 0, तो x2 का value t आएगा. And when you will put x2 as 0, तो x1 का value t आएगा. So you will notice that you will go ahead and get something like this. Now when I go ahead and I tell you कि x1 plus x2 is less than t, so you will shade inside राइट अच्छा नाउ इफ आई गो अहेड एंड आई टेक एनी पॉइंट बेटा ऑन द लाइन सपोज मैंने बोला यहाँ पे ये x1 है तो यहाँ पर ये पॉइंट x2 होगा एंड बिकॉज दिस इज ऑन द लाइन तो हमें पता है कि x1 प्लस x2 शुड बी इक्वल टू t वी नो दिस थिंग so from here can't I say that x2 will be t minus x1. So the coordinates of any point here, it can be rewritten as x1 comma t minus x1. I can go ahead and write the coordinates in this format, x1 comma t minus x1. This is what I have gone ahead and written here. So my x2 goes from 0 to x2, but x2 is t minus x1. And then x1 goes from 0 to t. x1 goes from 0 to t. And this is the joint distribution function. ये हमें joint distribution function दिया हुआ है. तो actually this is from last semester. ये हमारे लिए इतना relevant इस sem के लिए नहीं है. We have already done this thing. So what you can go ahead and do is you can first integrate with respect to x2, and whatever answer you will be getting, then you can integrate it with respect to x1. If there is still any doubt, I will take this in the doubt class. But as of now, this is how you can go ahead and you can solve this. Huh? So this will be your answer. अच्छा ये आपका CDF फंक्शन निकल के आएगा यहाँ से when you will integrate it. पहले आपने इसको with respect to x2 integrate किया, then with respect to x1 you will get your CDF function. So if I want to go to the PDF, then I know that I can just differentiate the CDF function and I will be able to get the PDF, right? So यहाँ से we can at any point of time get the PDF also. Okay, beta. Now let's go ahead to the next mechanism. So this is known as the simulation experiment. So simulation experiment will be rarely asked in exam. बहुत rare इससे question आता है कोई exam में, तो ऊपर ऊपर से समझ लेते हैं what this says. It goes ahead and it says that in this case, what we are going ahead and doing is we are going to use a computer software. तो मैं सिर्फ अपने computer के पास गई and I tell the computer कि देखो ये सारा मेरे पास population है and I want you to generate a sample. So I am not going to go ahead and do it myself. Rather, what I'm going to go ahead and I'm going to do is I am going to do it based on a computer software. Right, beta? तो यहाँ पर हमने usage of computer software करना है. And in order to do simulation, we need the following things. हमें इन सारी चीजों की जरूरत पड़ेगी. So the first thing that we need is called as statistic of interest. मतलब what am I interested in? Am I interested in finding the means? Am I interested in finding the medians? Am I interested in finding the mode? What am I interested in finding? That's the first thing I want to know. The second thing is what kind of population distribution am I talking about? Is it normally distributed, exponentially distributed? What kind of distribution is it जिसमें से मुझे sample निकालना है? Like for example, when you refer back to the start of the book, तो हमने start किया था कल का lecture saying that it's a Weibull distribution, right? So we must know what kind of distribution we are talking about from which we need to find out the sample. That's the second thing. The third thing is we need to know the sample size. कि कितना sample निकालना है? Do I need, जैसे for example, again if I go back to the example of the last class, we had a sample size of 10. हमने एक sample में 10 units रखे थे. And we need to know how many replications we require. So for example, in the last lecture, we know that we had collected 6 samples. तो एक ही population से कितने samples निकालने हैं और हर sample में कितना observation होना है, we need to go ahead and we need to know all of that. So this is our diagram which is given in the book. And if you see this diagram, it's very interesting to understand कि जैसे जैसे आप अपना sample size बढ़ाते जाते हो, as you increase the sample size, you will notice that you will be having better answers. You will be approaching the value of the population. And as you increase the number of the samples, जैसे बेटा यहाँ पर if you just go ahead and look here, I am just going to go to the example yesterday. तो यहाँ पर हमने कितने samples दिए थे बच्चे? We had gone ahead and we had taken 6 samples. So our expectation is कि जब हम इन 6 samples का mean निकालें, mean का mean, when I find out expected value of the mean, it will be close to the population mean. But the claim is कि as you increase the number of samples, जितने आप samples निकाल रहे हो population से, as you increase those, you will notice that it actually goes ahead and it becomes better estimate of the population. It becomes better estimate of the population. Am I clear with that part? Okay. So this is what is important from the simulation part. Not a lot of things important from there. बस इतना आपको याद रखना है that for simulation, we need this information. Where is it? Okay. So all you need to remember is that for simulation, we need this information, which means we need to know what is the statistic of interest, what is the population distribution, sample size and number of samples. उसके basis पे हम अलग-अलग number of samples and sample size generate कर सकते हैं. और जैसे जैसे हम number of samples जो generate कर रहे हैं वो बढ़ाएंगे, then it will become a better approximation. हमारा जो model बनता जाएगा वो एक better model बनता जाएगा. So before we do this section, I want to go ahead and I want to just revise what we did in the last class. So if you remember, we said that first of all, the population is not always at our disposal. पूरा का पूरा population हमारे पास हमेशा नहीं होता है. And because the population is not always at our disposal, therefore we need to go ahead and we need to work with the sample. Right, beta? So suppose someone goes ahead and they actually go ahead and collect the entire data of the population. अगर कोई जाकर सही में पूरा population का data collect करना चाहता है कि अच्छा ठीक है, so for example let's say I want to go ahead and I want to research about the income of people in India. मुझे जानना है कि लोगों की on an average income कितनी है. And let's say I start going to each and every household. मैं एक एक घर जा रही हूँ across different states and I start asking them, okay, how much is your income? How much is your income? How much is your income? ऐसे करके मैं एक एक का income पूछ रही हूँ. So if I collect the data of all the people in the population, अगर मैं एक एक इंसान का जितने भी लोग population में हैं, अगर मैं उन सब का डेटा कलेक्ट करूं, देन बेटा दैट इज कॉल्ड एज सेंसस. उसको सेंसस बोला जाएगा. सो सेंसस इज बेसिकली अ काइंड ऑफ अ सर्वे और whatever information you require, but you go ahead and you collect the information of each and every member of the population. आप हर एक इंसान से जो भी population में है हर एक से जाके डेटा पूछ रहे हो, then that becomes a census. So a census is when you go ahead and you ask each and every individual of the population. Now, since you have collected data of the entire population, there is no reason why you will be making any kind of error, right? It will be error free. Error free in the sense, kya matlab hai beta? So imagine, suppose due to some reason, I am not able to collect the information of all the people in India. And इसका एक बहुत बड़ा रीजन ये हो सकता है that the population is huge and I don't have time to collect information about every individual. हर इंडिविजुअल के बारे में जानने का, उसको समझने का कि उसके पास कितना इनकम है, I don't have time for that. So let's say what I do is I decide that from every state I will ask the income of say 500 people. From every state I will ask income of 500 people. And that will go ahead and become my sample. Now, what will happen in this case, beta? क्या problem आएगा इससे? One, it will be very timely process. जल्दी जल्दी ये काम हो पाएगा because now I just have to collect data of 500 people each. But it can create some error. हाँ, suppose ये जो 500 लोगों का data मैंने collect किया, these 500 people whose data I collected, let's assume that almost all of them were either middle class or rich people. Then this data will be very biased. ये जो sample होगा ये बहुत ज़्यादा biased हो जाएगा. So when I go ahead and I collect a sample and I use the sample for taking the information, yes, it is going to be a very timely process. Comparatively आसान है करना because you're just taking data of few people, but it can go ahead and it can lead to some kind of error. कुछ ना कुछ error हो सकता है. And therefore, when you talk about census, that means when you go ahead and you collect information फ्रॉम ऑल द पीपल, जब आप पूरा पॉपुलेशन का बात करते हो, जब आप सेंसस से इंफॉर्मेशन कलेक्ट करते हो, वी इंश्योर दैट दैट इज एरर फ्री। ये हमें गारंटी हो जाता है that because I have collected data of entire population, मैंने सबको ही ले लिया है, there is no reason why I will go ahead and make an error and it will become error free. Okay, अच्छा बेटा अब आगे देखो. So we are saying that whenever we collect census information, there are two main problems that we face. The first problem is very time taking process. अब imagine करो, India has such a huge population. इस पॉपुलेशन के एक एक इंसान से डेटा जाके कलेक्ट करना इज लिटरली इम्पॉसिबल टास्क. इट इज गोइंग टू बी वेरी वेरी टाइम कंज्यूमिंग एंड एट द सेम टाइम इट इज गोइंग टू बी अ वेरी एक्सपेंसिव टास्क ऑल्सो. क्यों एक्सपेंसिव होगा बच्चे? बिकॉज आई हैव टू ट्रेवल सो मेनी सिटीज, आई हैव टू ट्रेवल सो मेनी हाउसेज, राइट? There is going to be a huge opportunity cost involved also. You are an economic student, you know what is the meaning of opportunity cost. So we understand that number one, this is going to be a very time taking process. Number two, it is going to be a very expensive process. बहुत महंगा होगा, बहुत पैसा लगेगा, बहुत time भी जाएगा. So therefore, this is literally an impossible task to be done. ये करना एकदम ही impossible चीज है, right? So since I cannot go ahead and I cannot collect information related to each and every person, I cannot go for the population. Therefore, I must go ahead with the sample. So the जो best चीज है that I can go ahead and I can do is work with a sample. So what I want to do, because this is impossible, I cannot work with the census, I cannot work with the population. Therefore, I must go ahead and I must work with the sample. अब next question ये आता है, how can I go ahead and how can I collect the sample? There are multiple ways to collect the sample and you must have read about some of the ways. आपने शायद सुना होगा something called as random sampling, stratified sampling, and many other ways, हाँ, snowball sampling, etc., etc., etc. तो सैंपल कलेक्ट करने के बहुत अलग अलग तरीके हैं. There are multiple ways to go ahead and collect the sample, but one of the easiest way of collecting sample, that is known as random sampling. Now, what do we do in random sampling? So imagine something like this. Suppose I want to go ahead and I want to collect data. तो मैं क्या करूंगी ना? Say there are these 500 houses in this region. House number 1, house number 2, house number 3, and so on. House number 500. So I will create 500 chits. Chit 1, chit 2, chit 3, and so on till chit 500. And I will put it in a box. मैंने एक box के अंदर इसे रख दिया and I will just shake it. I will just spread it around. And then I will ask you कि ठीक है बेटा, मेरे को 50 houses का sample चाहिए. Start picking up chit. तो आपने पहला chit उठाया, you open up that chit, the number comes as 45. तो house number 45 will be part of my sample. फिर आपने दूसरा chit निकाला and that comes out as 387. So house number 387 will be part of my sample and so on and so forth. So in that sense, we are ensuring that this is completely random in nature. Now, in the real world, beta, we don't even have to go ahead and do this thing. हमें ये करने का भी जरूरत नहीं है. We don't have to go ahead and we don't have to do this thing. Rather, what we can go ahead and we can do is use some or the other software. So when you go ahead and you use software like R, Stata, Python, जब आप ऐसे softwares use करते हो, you ensure that you are going ahead and doing random sampling. हाँ, R में एक option होता है which is called as set seed, which helps you to go ahead and collect a random sample. ऐसे ही Stata में, Python में भी होता है which helps you to collect a random sample. So you can go ahead and you can work with random sampling. और वो random sample के लिए काम करने के लिए what is required बच्चे? You just have to use a software. और पहले के टाइम पे जब statisticians करते थे, they would go ahead and make these chits and pick up the chits to ensure that it is completely random in nature. Clear हो गई बात? Okay. Now क्वेश्चन ये आता है कि what is the problem when we use the sample? जब हम sample use करते हैं तो problem क्या आती है? What problem do we incur? The first problem that we go ahead and we incur is that there are multiple ways of collecting the sample out of the population. तो जैसे बेटा मैंने आपको बुलाया, हाँ, I called student number A, मैंने बोला अच्छा इसमें से बेटा 50 houses का sample collect करो, तो शायद आपके 50 houses होंगे, house number 45, house number 387, house number 500 and so on. But suppose I go ahead and I ask student number B कि बेटा collect इसमें से 50 chits निकालो and give me a sample. Maybe the chits he has picked up is house number 1, house number 7, house number 28 and so on. So the sample that you have created will be different from the sample that person number B will create. It will be different from the sample that person number C will create. तो हर individual एक अलग sample create करेगा. And since each individual will go ahead and each individual will collect a separate sample, they will collect a different sample. Therefore, the answers that I will get from the sample will be very different. मतलब शायद ऐसा हो सकता है कि जो इंडिविजुअल नंबर ए ने सैंपल कलेक्ट किया हो 50 ऑब्जर्वेशंस का, when I go ahead and I find the mean of this 50 observation, maybe I observe that the mean comes out to be 402. Average income comes out to be 402. But when I ask individual B and he picks up 50 chits out of the sample, so the average income comes out to be 450. So it is possible that because they have collected different samples, the average that they will be getting will be very, very different. And this is exactly beta what we studied in the last section, 5.3. So if you remember, when I did that example, जो हमने कल एक example किया था, which talked about 2 GB, 4 GB and 8 GB RAM, and which talked about their revenues, तो उसमें हमने दिखाया था कि how from sample to sample, the average was differing. Average could have been 80, average could have been 90, average could have been 100 and so on. So the average actually differed. So we showed how from sample to sample, the average mean can differ. Now, if you remember, we had gone ahead and we had called the mean value as the statistic, right? The mean value of the sample, it was called as statistic. And our aim was to go ahead and to see that this is as close to the value of the population parameter. और अगर आपको याद हो तो in the example that we had done as part of section 5.3, हमने ये actually बात show की थी कि जब हम mean का mean निकालते हैं, when we go ahead and we find the mean of the mean, it was coming equal to the mean of the population. But please go ahead and look into that video and come. It will be very useful because yesterday we have proved this in an example that the mean of the mean was coming equal to the mean of the population. Similarly, we had actually gone ahead and proved that when we go ahead and find the expected value of the variance of the sample, it was coming equal to the variance of the population. Am I right? So try to understand from here. I am saying that when whatever samples we have picked up, so if you remember, हमने बोला था कि ठीक है, हमारे 9 sample निकल रहे थे. I will just take you quickly to that example. So this was the question which we had done. This was the question that I had gone ahead and I had taken. This one, huh? You remember, this is the question we had gone ahead and taken. And I had shown you that these were the 9 samples that we had. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or depending on what sample we had collected, जो भी हमने sample collect किया था, based on the sample we had collected, we were getting the sample mean. So the sample mean differed. The sample mean was not equal to the population mean. हमारा जो population mean था वो अलग था and sample mean were very, very different. But what we proved is that if I go ahead and I find the mean of these sample means, if I sum up all these sample means and divide it by the number that we have, if I go ahead and I find the mean of the sample mean, in this case, इनका एक probability distribution बना था like this. So when we go ahead and we find the mean of the sample mean, so we had actually found out that it was equal to the mean of the population. वो population के mean के बराबर था. This is what we had gone ahead and we had found out. You remember that from the last section? Okay. Now we will come back to what we were doing here. So basically what we have therefore is that हर sample का जो statistic होगा उसका value अलग होगा, right? एंड हमारा एम ये है कि जब भी हम कोई भी सैंपल पिकअप करें, इट शुड बी एज क्लोज टू द पॉपुलेशन एज पॉसिबल. उस सैंपल से जो भी हमें आंसर मिले, इट शुड बी क्लोज टू द पॉपुलेशन, इट वुड बी अ गुड एस्टिमेट ऑफ द पॉपुलेशन. ओके बेटा, अब हम बात करते हैं सेंट्रल लिमिट थ्योरम का. लेट अस टॉक अबाउट CLT. So now try to go ahead and try to understand that when we talk about the central limit theorem, what it is saying. Let x1, x2 and xn be the random sample from a distribution with mean mu. तो हमने क्या किया है ना, हमने एक पॉपुलेशन ली है, इसको बार बार दूसरे जो हमने कल एग्जाम्पल किया है, ट्राई टू कंपेयर इट विद दैट एग्जाम्पल. तो उस एग्जाम्पल में द मीन ऑफ द पॉपुलेशन वॉज 106. फिर हमने इस पॉपुलेशन से सैंपल बनाए थे, तो हमारे पास 9 सैंपल्स क्रिएट हुए थे. सैंपल 1, सैंपल 2 एंड सो ऑन टिल सैंपल 9. वी वर एबल टू क्रिएट 9 सैंपल्स. अब हम कह रहे हैं लेट x1, x2 टिल xn बी रैंडम सैंपल फ्रॉम दीज डिस्ट्रीब्यूशन. तो ये हमारे अलग अलग सैंपल क्रिएट हुए थे. According to the last example that we did in the last lecture, there were 9 samples that were created. ठीक है, और पॉपुलेशन का मीन जो है वो 106 था, और पॉपुलेशन का वेरिएंस सिग्मा स्क्वायर है. इफ n is sufficiently large, then x bar approximately is normally distributed. तो अगर ये जो सैंपल है ये बहुत लार्ज सैंपल है, इफ द साइज ऑफ द सैंपल इज लार्ज इनफ, तो हम ये कह रहे हैं दैट द सैंपल विल बी अप्रोक्सीमेटली नॉर्मली डिस्ट्रीब्यूटेड. हम एज्यूम कर सकते हैं that it will be normally distributed. And in particularly क्या normally distributed होगा, अगर हम इन सैंपल की मीन वैल्यू निकालते हैं. If I find out the mean value of these samples और उसको मैं प्लॉट करती हूँ, it will be normally distributed. Am I clear with this बेटा? तो ध्यान से वापस एक बारी देखो. The central limit theorem is of utmost importance and it is one of the most important thing that we have to understand in statistics. So try to understand this thing. We are saying I have a population. From this population, I want to create a sample. There can be many samples that can be created. So from this population, I can take sample 1. So suppose example, I have a population of 500 and I need to take a sample of 50. So I can take this in many ways. I can create sample 2, I can create sample 3, I can create sample 4 and so on and so forth. Each of them has 50 observations. Now I am saying that I am finding the mean of sample 1, I am finding the mean of sample 2, mean of sample 3, mean of sample 4 and so on. Now I am saying, of course, from the last example you will remember कि ये जितने भी हमारे पास mean आ रहे थे, I can go ahead and I can create a probability distribution out of these means. इन means का ना हम एक probability distribution बना सकते हैं कि अच्छा अगर mean 80 है तो इसका corresponding probability कितना, अगर mean 90 है तो इसका probability कितना, अगर mean 100 है तो इसका probability कितना, 110 है तो probability कितना, and so on and so forth. So I can go ahead and I can create a probability distribution associated with these. मैंने इससे related एक probability distribution बना दिया. Now I am saying that if the sample size is large enough, अगर जो हमने ये sample निकाले थे, if these sample size is large enough, I will tell you what large enough means. कितना large हम उसको मान सकते हैं. We will talk about that. But as of now, I am going ahead and saying that if the sample size is large enough, then if I go ahead and I try to plot this x bar, अगर मैं इस x bar को plot करने की कोशिश करूं, then this x bar will come out to be approximately normally distributed. इसका जो distribution बन के आएगा, it would be approximately normally distributed. So let us try to read this out, beta. I am saying if x bar, if n is large enough, then x bar is approximately normally distributed. Actually ये वाला बात तो हमने कल ही प्रूव कर दिया था, even with small sample, that I had already proved this in the last lecture, that if I try to find out the mean of these x bars, then I will get the mean of the population, right? So this is what this is saying. If you find the mean of these x bars, you will get the mean of the population. And in fact, the other thing also we proved that if I find out the expected value of the variance, right, then I will get the expected value, I will get the variance of the population. But this has been written in another way, that if you go ahead and you find out the variance of this x bar, this is another thing you have to remember, then it will be equal to the variance of the population divided by n. Variance of the population divided by n. तो ध्यान से हम एक बार सेंट्रल लिमिट थ्योरम को समझ लेते हैं. The central limit theorem goes ahead and says you have a very big population. उस population से आपने अलग अलग सैंपल निकाले, उन सैंपल्स का आपने मीन निकाला. अगर जो भी अलग अलग सैंपल निकाले हैं, when you find the mean of each of the sample, अगर इन मीन का दोबारा आप मीन निकालोगे, अगर आप इन मीन का मीन निकालोगे, it will be equal to the mean of the population. और अगर आप इन मीन का वेरिएंस निकालोगे, it will be equal to the variance of population divided by n. This is what the central limit theorem is saying. Am I clear with it? Okay, beta. अब बहुत ही interesting portion है. Let's try to continue this. So this says, and T naught has approximately normal distribution with this and this. अच्छा एक बात बताओ. But I have told you that the mean of x bar is equal to mean of the population. Mean of x bar माने क्या? When you sum all x bar and divide by n, it is equal to the mean of the population. It means that all the summation of x bar should be equal to the mean of population into n. Beta, this means the sum of x bar, that means the totals. So I can go ahead and say that the total, it is having the value as n mu. It is having the value as n into mu. ये देखो यहाँ पे, come back here. So we are saying that if I find the mean of the totals, that means if I go ahead and I sum these totals around, then it will be equal to n into mu. So the mean of the totals will be equal to n into mu, and the variance of the totals will be equal to n sigma square. अब क्वेश्चन ये है कि कितना बड़ा n होना चाहिए, how big the n should be. So the rule of thumb is that as long as my n is greater than equal to 30, so the central limit theorem will hold true. तब तक CLT hold true करेगा. Okay, beta. Now let us try to go ahead and revisit the concept once. It is a very, very important concept. जितनी बारी देखोगे उतनी बारी कम है. So we are saying that, क्या कह रहे हैं हम, that if I have a population and I pick up a sample from this population, मैंने इस population से अलग अलग sample निकाले, sample 1, sample 2 and so on till sample n, और हर sample का मैंने mean निकाला, then if I find the mean of these means, then it will be equal to the mean of the population. And if I find the variance of these means, then it will be equal to variance of population divided by n. Acha, now, beta, if I just ask you what will be the standard deviation of the mean, so how do we find the standard deviation? We give the under root of the variance. So this is going to be under root of sigma square by n, and this is going to go ahead and give you sigma by root n. Beta, this value that you have got here, इसको हम standard error भी बोलते हैं. This value is also called as the standard error. This value is also called as the standard error. अब error क्यों? Why error? Because if you remember, then we have said that whenever you collect a sample, you can commit some kind of error. जब भी आप कोई भी sample collect करते हो, आप किसी ना किसी तरीके का error कर सकते हो. Why? Because the sample will deviate from the population. Just take another example. तो जैसे अगर मैं बोलूं कि population is of 500 people who are telling me whether they voted for party A or party B, political party A or political party B, and I create a sample of 50 people, तो बेटा यहाँ पे जो भी मेरा result आएगा, suppose this 50 people, 40% say they voted for A and 60% say they voted for B. So in reality, when the actual results will come out, maybe it will be the case that actually 50% had voted for A and 50% had voted for B. So the sample that you have collected, there may be some error that you might have committed. सैंपल में जो भी आपका इंफॉर्मेशन आ रहा है, whatever answer you are getting, it is going to be close to population, but it will not be exactly equal to population. There will be some error that you will be committing, and that error becomes the standard error. So the formula for standard error is basically called as sigma by root n. It is called as sigma by root n. Am I clear with it? Okay, beta. So this is also known as the standard error of the sample mean. And why I am committing error, I have also cleared this out. Okay. Next thing that we want to go ahead and focus on is that as the sample size increases, जैसे जैसे n का value बढ़ेगा, as the sample size increases, you will be going towards closer and closer normal distribution. अब इसको समझने के लिए we can go ahead and refer to this diagram here. So if you go ahead and you notice, beta, this is your population distribution. This is how population is distributed, right? And what we are saying is that this is your sample size for small sample n. So this is, for the population, the mean value is this. ये आपका mean value है. ठीक है? This is for a smaller to moderate n, small values of n, maybe n का value 10, 15, 20 रहा होगा. And this is for larger values of n. यहाँ पे n is large. Now you need to go ahead and you need to notice that as the size of the sample is increasing, देखो यहाँ पे the size of the sample is small. तो जब sample size small है, we go ahead and we realize कि हमारा sample के mean से deviation है, population mean से deviation है. This is my population mean, which is mu. और sample mean average यहाँ आ रहा है, where it takes a peak, right? Where it takes a peak. Now you need to realize that as my sample size is increasing, तो ये जो distribution है, it gets centered around the population mean. It gets centered around the population mean. So it becomes a better approximation of population mean. So as your sample size increases, we can go ahead and we can say that it becomes a better approximation of the population means. It becomes more closely concentrated around the population mean. ज़्यादा population mean के पास होना शुरू हो गया है. Also, it becomes more and more normally distributed. Okay, so now we have also talked about T naught. T naught refers the total of the observation, and it is also approximately normally distributed. Here you have n mu, and here you have n sigma square. Okay, so we have talked about this also. The larger the n, the better the approximation. Okay, beta. Now we need to go ahead and take this example. So here, example number 5.26. Please read this example. It says the amount of particular impurity in a batch with chemical has mean value 4 gram. So you are given that the mean of the population is 4. And it says that the standard deviation of the population is 1.5 and the size is 50. So मैंने आपको बोला that central limit theorem holds well if the sample size is greater than or equal to 30. And here, since the size is 50, so we know that the central limit theorem will hold pretty well. Okay. Are independently prepared, what is the probability that the sample average amount x bar is between 3.5 and 3.8 gram? So the question is, we need to find out what is the probability that x bar is between 3.5 and 3.8. अब मेरी बात बहुत ध्यान से सुनना. Because n is greater than 30, we will write this line. So because n is greater than 30, the central limit theorem holds true. And since the central limit theorem holds true, we can say that x bar is approximately normally distributed. And since x bar is approximately normally distributed, what can we do, bache? We can go ahead and we can convert this in the form of a Z variable, in the form of a standard normal variable. We can convert this in the form of a standard normal variable. And how do we convert this in the form of a standard normal variable? Very simple. It will be x bar minus mu upon standard error of x bar, or standard deviation of x bar, as you may say. So x bar minus mu upon its standard deviation was sigma by root n. Its standard deviation was sigma by root n. So let us try to go ahead and let us try to convert this now. So if I just try to convert this beta, I will get 3.5 minus mu upon sigma by root n less than x bar less than 3.8 minus mu upon sigma by root n. Am I clear? You are already given that mu is 4. You are given that sigma is 1.5. So sigma by root n, but that will be 1.5 divided by root 50. And this is going to be 0.2121. This will be 0.2121. So now I just need to go ahead and I need to plug these values here. So you're given that mu is 4. I've plugged 4 here. Sigma I have plugged here 1.5. And root n, that means I've plugged the value here. Right? Now when you will solve this, you will get this. But we know this is normally distributed. So I can get the values from the normal table. I can always go back to the table and I can get the values. We have already studied how to read a Z table, isn't it? So if I just go ahead and look here, beta, हमने CDF, PDF पढ़ा है. अब यहाँ पे देखो, if I just want to go ahead and I want to shade this region, so this is minus 2.36, I have written it here. And this is minus 0.94, I have written it here. And I want this region. I want to calculate this probability. Isn't it? So if you go ahead and you really look into it, you will understand that if I take 0 here, and I take minus 0.94 here and minus 2.36 here, at any point of time, I can go ahead and I can find out this region first. This region. Isn't it? At any point of time, I can go ahead and I can find out this region. So I can call this as the cumulative distribution till 0.94. So you go to the Z table, you find out ki minus 0.94 kahan pe aa raha hai, and you find out the corresponding probability. Minus, you find out this region. Minus, you find out where minus 2.36 is coming. So when you will be subtracting that 2, you will be able to get this region. Right? So I hope all of you know how to read the Z table. If not, just tell me. I will post a video on that. But you should know how to read the Z table. So from there, you will be able to get the answer. But the question here is, why were we able to go ahead and use the Z table in the first go? We were able to go ahead and we were able to use the Z table because we could use the central limit theorem and we could go ahead and say that it is actually normally distributed. Right? Okay, beta, take this example now. This is very interesting example. So example 5.27 of Devore, try to read it out. So what it is saying is that let X be the number of defects. And the mean of the population is given as 3.2 and the sigma is given to you as 2.4. And you're given that the sample size is 100. Right? And it is asking what is the probability that the mean will be more than 4. Now, why this question is interesting in this case is that beta, try to understand that we are talking about the number of defects. And number of defects जो होते हैं, it is actually a discrete variable. ये एक normal variable तो ये एक continuous variable तो है नहीं, it's a discrete variable. And when I talk about normal distribution, तो normal distribution तो actually continuous variable के लिए काम करना चाहिए. But the exciting part here is that because n is large enough, क्योंकि n का size 30 से बड़ा है, because n is large enough, and I am talking about the distribution of the mean values, we can go ahead and say that it will be normally distributed. even though x is representing discrete variable, x एक discrete variable को represent कर रहा है, even though x represents a discrete variable, I am able to go ahead and use a normal distribution on it using the central limit theorem, because I am talking about distribution of the mean, first thing, and secondly I am talking about sample size greater than 30. ठीक है बेटा. So now I want to go ahead and I want to find out what is the probability that the mean is more than 4. So what can you go ahead and do? Again, because central limit theorem can be applied, you will convert this in standard normal variable. So minus mu upon sigma by root n greater than 4 minus mu upon sigma by root n. You can go ahead and put the values. So sigma का value आपको already given है बेटा. Your given sigma is 4. X bar आपको check करना है at 4. So this is Z value. So this will be probability Z greater than 4 minus mean दिया हुआ है 3.2, sigma दिया हुआ है 2.4 divided by root 100. So when you will go ahead and find this value, you will get this value as 3.33. फिर से एक बारी अगर हम टेबल की तरफ जाएं, if I just try to make a diagram out of it, so I need to find out, this is my 0, यहाँ पे कहीं पे 3.33 होगा. I need to find out this region. I need to find out this region. But isn't this 1 minus? Because I know that total will be 1. So out of 1, if I subtract this region, I will get this region. So this is nothing but 1 minus probability Z less than equal to 3.33. Right? So this is nothing but this is 1 minus cumulative distribution of 3.33. This is going to be this. Again, but this value you can find from the Z table. Z table पे जाके ये value you can easily find it out. So once you find this value, you will be able to go ahead and get the answer for this one. I think the Z value came out to be, after this, the answer came out to be 0.0004. Okay. So now, this is another thing which we should be highlighting here, which I've already highlighted, that the central limit theorem only works well if your sample size is greater than 30. But one last thing that I want to discuss today is the other application of the central limit theorem. तो एक बारी हम ये भी देख लेते हैं कि central limit theorem का और कहाँ पे application होने वाला है. तो इसमें ऐसा कुछ एक एग्जाम्पल देखो कि सपोज आई एज्यूम दैट x इज अ बाइनोमियल वेरिएबल. तो बाइनोमियल वेरिएबल जस्ट टेक्स टू वैल्यू, ईदर सक्सेस और फेलियर. तो x जैसे x कैन रिप्रेजेंट द नंबर ऑफ हेड्स व्हेन n coins are tossed. तो getting a head can be represented as success and getting a tail can be represented as a failure. So whenever we talk about a binomial variable, उसमें success and failure दो चीजें होती हैं. So what I have done is let x1 go ahead and represent, x1 represents 1 if success and 0 if failure. तो हमने ऐसा कुछ represent कर दिया कि when the first coin is tossed, जब हमने पहला coin toss किया, so it will be x1 will take the value 1 if I get head in it, and x1 will take the value 0 if I get tail in it. Then I toss the second coin, so x2 will get the value 1 if I get head in it, and x2 will get the value 0 if I get tail in it. So ऐसे करके we have gone ahead and we have created x1, x2, x3 so on till xn. हमने x1 to xn को generate कर दिया है. Now what we go ahead and we say is that xi's are identically and independently distributed. तो क्यों identical है? क्योंकि हर एक में probability head आने का भी half है और tail आने का भी half है. So they have similar distribution. And why they are independent? क्योंकि पहले coin में head आया, it has got nothing to do with second coin में head आएगा या tail आएगा. So they are identically and independently distributed. Now in this case, बच्चे, the central limit theorem goes ahead and says that if n is large enough, अगर हमारा sample size large enough है, if n is large enough, then in that case, summation xi's and mean of xi will be normally distributed. तो ये जो हमारे xi's हैं, हर xi एक event था कि head आ रहा है या tail आ रहा है. अगर हम इन xi's का sum निकालते हैं या mean निकालते हैं, then they will be normally distributed. So this is one of the applications of central limit theorem. Now there are some conditions for the binomial distribution to be normally distributed. So the condition is that we want that the probability should be close to half. It should be close to 0.5. माने I don't want it to be very skewed. इतना चलेगा कि ठीक है probability of success is 0.55 and probability of failure is 0.45. That is fine. Itna skewness chalega. But I don't want ki probability of success is 0.90 and probability of failure is 0.10. If this is the case, probability of success, failure, success, failure. If this is the case, then I cannot say that the summation of xi will be normally distributed. ये हम नहीं बोल सकते हैं. But if this is the case, then we can go ahead and say that xi's will be, summation of xi's will be normally distributed. The condition for binomial distribution to be normally distributed is when the p's are close to 0.5 and when you have n into p greater than 10. Beta, इसी को rewrite करके we can also say that n into 1 minus p, that means n into q should also be greater than equal to 10. तो अगर ये दो condition हमारा satisfied होता है, if we have p close enough to 0.5 and np greater than equal to 10, then we can go ahead and say that in such a case, the binomial distribution follows central limit theorem. Okay, this is the last proposition of section 5.4. So this proposition ko ek bari we can go ahead and we can study. Let x1, x2 till xn be random sample from distribution with positive value. Probability of each xi greater than 0 is 1. Then if n is sufficiently large, then the product xi is approximately log normal distributed. This is just for your extra information. कि अगर हम एक वेरिएबल क्रिएट करते हैं y और हम सम नहीं कर रहे हैं, हम मीन भी नहीं निकाल रहे हैं, rather हम प्रोडक्ट निकाल रहे हैं, we are finding the product, then this product, it would be log normally distributed. It would be log normally distributed. So if I go ahead and I find the mean, then it is normally distributed. If I find the sum of xi's, it is normally distributed. But if I go ahead and I find the product of these xi's, then the product will be log normally distributed. Right, beta? Okay, so with this, we finish section 5.4. Okay. Now let us go ahead and talk about section 5.5 of Devore today. And in this section, we are going to talk about the distribution of the linear combination. ध्यान से समझने की कोशिश करेंगे बेटा. Let us try to say that we have y is equal to ax1 plus ax2 and so on till axn. देखो यहाँ पर ध्यान से समझने की कोशिश करो. We are going ahead and saying that, well, let y be some linear combination of x's. Linear combination का क्या मतलब होता है? What is the meaning of linear combination? Linear combination basically goes ahead and means कि अगर suppose बेटा मैं ऐसा कुछ लिख दूं आपको कि y is equal to 4x1 plus 3x2. मतलब x1 and x2 को हमने कोई power नहीं दी है. So this is going to be a linear combination that we are going to go ahead and have. There is no power that I am allotting to x1 and x2. So it's a linear combination. तो यहाँ पर हमने ये बोला कि y is some linear combination of x's. और यहाँ पे एक बहुत important चीज है that we need to understand here, that ये जो भी हम x's ले रहे हैं, whatever x's we are taking, these x's are random in nature. ये जो हमारे x's हैं, these are random variables. राइट बेटा? तो ट्राई टू अंडरस्टैंड कि y जो है वो लीनियर कॉम्बिनेशन है एक्सेस का, और ये जो एक्सेस हैं ये रैंडम वेरिएबल हैं, और हर एक को हमने कुछ वेटेज दी है रैंडम वेरिएबल को, और जो वो वेटेज है वो ये वेटेज है a1, a2 एंड सो ऑन टिल an. सो जैसे हम यहाँ पर वी कैन गो अहेड एंड वी कैन सी दैट व्हेन आई गो अहेड एंड आई राइट y इज इक्वल टू 4x1 प्लस 3x2, तो यहाँ पे हमें देखना होगा कि हमने x1 को जो वेटेज दी है that is 4 and x2 को हमने जो वेटेज दी हुई है that is 3. So we have given a weightage of 4 to x1 and 3 to x2. ऐसे ही हमने एक जेनरिक केस लिया. We have gone ahead and taken a generic case And in that generic case, we are saying y is equal to a1 x1 plus a2 x2 and so on till an xn. बेटा, this can also be rewritten. इसको आप ऐसे बिल्कुल बेटा just try to imagine कि suppose ये जो weightage है, मैं इस weightage को ऐसा कुछ बोल दूं कि let a1 be equal to a2 be 1 by n के equal. I have given each x weightage equal to 1 by n. तो इस केस में what will happen ना, I can write y is equal to 1 by n x1 plus 1 by n x2 and so on till 1 by n xn. ऐसा कुछ हो जाएगा, y is equal to 1 by n x1 plus 1 by n x2 and so on till 1 by n xn. अब यहाँ पर थोड़ा सा अगर हम नोटिस करें, so you will go ahead and you will realize कि this is nothing but x1 plus x2 till xn divided by n. And this is nothing but summation x by n, which is nothing but mean. So basically what we are going ahead and we are saying is that for some value of a की कोई एक ऐसी वैल्यू होगी जिसके लिए ये जो है, जो हम ये लीनियर कॉम्बिनेशन बनाने की कोशिश कर रहे हैं, एक्चुअली ये मीन के इक्वल हो जाएगा. इट विल बी इक्वल टू द मीन ऑफ द रैंडम वेरिएबल. राइट बेटा? In very similar fashion, suppose हम ये assume कर लेते हैं, again I go ahead and I take another example. तो हमने लिया कि y is equal to a1 x1 plus a2 x2 and so on till an xn. हमने y को ऐसे ले लिया. And now I am going ahead and I am saying कि okay, let it be the case that a1 is equal to a2 is equal to till an is equal to 1. जितने भी एक्सेस हैं उनको जो हम ये वेटेज दे रहे हैं, वी आर गिविंग देम अ वेटेज ऑफ वंस. तो बेटा कैन आई गो अहेड एंड कैन आई राइट दिस एज x1 plus x2 and so on till xn, and this is nothing but this is the sum of the random variables. तो in the last class we had mentioned कि जब भी हम sum निकालते हैं, that is represented by the totals. तो फॉर सम वैल्यू ऑफ ए, किसी वैल्यू ए की एक वैल्यू के लिए ये जो लीनियर कॉम्बिनेशन है, इट टर्न्स आउट टू बी द मीन. और y की और a की ही किसी और वैल्यू के लिए ये जो लीनियर कॉम्बिनेशन है, इट टर्न्स आउट टू बी द टोटल. सो इट मीन्स दैट ये सेम लीनियर कॉम्बिनेशन जो है, इट कैन टेक डिफरेंट वैल्यूज based on the weightage that you give. जो हम a की वैल्यू रखेंगे, जो हम weightage देंगे, उसके बेसिस पे ये जो हमारा लीनियर कॉम्बिनेशन है, इट विल गो अहेड एंड इट विल टेक डिफरेंट वैल्यूज. वो अलग अलग वैल्यूज ले लेगा. एम आई क्लियर विद इट? ओके बेटा, अब हम क्या बोल रहे हैं ना कि लेट अस डिफाइन दीज रैंडम वेरिएबल्स अ लिटिल मोर. तो हम कह रहे हैं कि लेट द मीन ऑफ x1, अगर मैं ये जो भी मेरा x1 रैंडम वेरिएबल है, अगर इसके मैं मीन निकालती हूँ, let this be mu1, let the mean of x2 be mu2 and so on till mean of xn be mu(n), and let the variance of x1 be sigma 1 square, variance of x2 be sigma 2 square and variance of xn be sigma n square. ये हमने ऐसे डिफाइन कर दिया. Then बेटा we have the following properties. Property number 1, बहुत ध्यान से सुनना मेरी बात को. If I go ahead and I write y is equal to a1 x1 plus a2 x2 and so on till an xn, and मैं इसका एवरेज निकाल रही हूँ, एक्सपेक्टेड वैल्यू निकाल रही हूँ. सो द एक्सपेक्टेड वैल्यू ऑफ y will be expected value of a1 x1 plus a2 x2 and so on till an xn. Now beta, I can open this up and I will get expected value of a1 x1 plus expected value of a2 x2 plus expected value of an xn. बेटा whenever we have a constant, देखो ध्यान से समझने की कोशिश करो. सपोज मैं बोलती हूं आपको कि फाइंड द मीन ऑफ दिस 1 2 and 3. तो 1 2 and 3 का जब आप मीन निकालोगे, वी नो इट इज गोइंग टू बी 2. अब मैंने क्या बोला, मैंने बोला मैं इस x को ना एक नंबर से मल्टीप्लाई कर रही हूं. आई एम मल्टीप्लाइंग ईच x वैल्यू बाय 2, तो दिस बिकम्स 2 4 and 6. And I ask you, beta, what will be the mean of this x? आप निकालोगे, you will get the answer as 4. So when I multiply each value by 2, तो इसका जो mean है, that also gets multiplied with 2. So basically there is this simple property कि जब आप सारे x's को किसी constant से multiply करते हो, that constant can come out and it will be पहले आप mean निकालो और mean को सीधा constant से multiply. Right? So in this case, we follow exactly the same property. So beta these A1, A2 till AN, these are constants. So agar ye constants hain, what I can go ahead and do, I can bring these constant out. So this will be A1, E of X1 plus A2, E of X2 and so on till AN, E of Xn. और बेटा E of X1 क्या है? mu1. It's the mean of X1. So I can write this as A1 into mu1 plus A2 into mu2 and so on till AN into mu1. तो यहां से हमें एक बहुत इंपॉर्टेंट प्रॉपर्टी मिल गई that the expected value of y, अगर मैं y का मीन निकालने की कोशिश करूं, remember y is a linear combination of x, y एक्सिस का लीनियर कॉम्बिनेशन है और अगर हम y का मीन निकालते हैं तो वो एक्सिस के जो मीन्स हैं उनका लीनियर कॉम्बिनेशन होगा. इट विल बी अ लीनियर कॉम्बिनेशन ऑफ द मीन्स ऑफ दीज रैंडम वेरिएबल. Right? Clear? So I will just jot this down property for you. So please write this down, beta, that if y is linear combination of x's, then the expected value of y will be linear combination. This is expected value of y will be linear combination of the mean of x's. That means of these mu's. Clear? अच्छा, अब थोड़ा सा आगे बढ़ते हैं. Now let's talk about the variance. तो बेटा when we have to talk about the variance of y in this case, so there are two cases that we need to follow. Case number 1 हो जाता है if your x's are independent. And case 2 हो जाता है if your x's are dependent. So case 1 is what happens when your x's are independent of each other. And case 2 हो जाता है what happens when your x's are dependent with each other. If your x's are independent, beta, तो variance of a1 x1 plus a2 x2 and so on till an xn. इसको हम लिख सकते हैं a1 square variance of x1 plus a2 square variance of x2 till an square variance of xn. This can be written like this. Now this is very very important. ये बहुत 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 important property है. क्यों? ध्यान से सुनो मेरी बात को. Suppose बच्चे, I tell you that x1 and x2 are independent of each other. मैंने आपको बोल दिया कि x1 और x2 इंडिपेंडेंट है. दे आर इंडिपेंडेंट ऑफ ईच अदर. और अब मैं आपसे एक इंपॉर्टेंट क्वेश्चन पूछती हूँ कि डज इट मीन दैट वेरिएंस ऑफ x1 प्लस x2 विल बी इक्वल टू वेरिएंस ऑफ x1 माइनस x2? विल बी इक्वल टू वेरिएंस ऑफ माइनस x1 प्लस x2? विल बी इक्वल टू वेरिएंस ऑफ माइनस x1 माइनस x2? क्या ये चारों ही वेरिएंस इक्वल आएंगे? विल दीज फोर वेरिएंस बी इक्वल टू ईच अदर? The answer is yes. क्योंकि हमारा property, what our property says is that if I have variance of x1, x2, so if I note down, so beta here a1 is 1 and a2 is also 1. Here a1 is 1, a2 is minus 1. a1 is minus 1, a2 is 1. a1 is minus 1, a2 is minus 1. Isn't it? So if I were to go ahead and I were to find the formula of their variance, so bache, what will I write this as? 1 square variance of x1 plus 1 square variance of x2. This will be variance of x1 plus variance of x2. But if I just find out iska, so what will happen? So it will be 1 square variance of x1 plus minus 1 square variance of x2 This will be variance of x1 plus variance of x2. Same. If I find out for this one, what will I get? I will get minus 1 square variance of x1 plus minus 1 square variance of x2. So I will get variance of x1 plus variance of x2. Same happens in this case. Verify. So whether when x1 and x2 are independent of each other, अगर x1 और x2 independent हैं एक दूसरे के साथ, so what will happen in this case, बच्चे, we can go ahead and say that variance of x1 plus x2 and variance of x1 minus x2 will be actually equal to each other. An important question from exam point of view. बहुत सारे बच्चे बहुत बच्चे इसमें ये गलती करके यहाँ पर दे राइट वेरिएंस ऑफ x1 माइनस वेरिएंस ऑफ x2. इट इज इनकरेक्ट, एकदम गलत है. whether this is negative sign or positive sign, remember the formula. और formula है you are doing a1 square variance of x1, a2 square variance of x2 and you're putting plus in between, isn't it? तो अगर मैं उस फॉर्मूला की तरफ से जाऊं, if I just follow that formula, तो a1 is 1 and a2 is minus 1. So a1 square variance of x1 plus a2 square variance of x2. So variance of x1 plus variance of x2. That is going to be the answer. Please note this down. Both of them will be equal to each other. ये बहुत important है note down करने के लिए. Okay बेटा, if they are not independent of each other, अब थोड़ा ध्यान से हम यहाँ पे let me create some space here. तो सपोज अब हमारे पास होता है कि x1 and x2 are not independent of each other. तो in this case the variance of y will be this. राइट बेटा? अच्छा अब ध्यान से देखो, I will start putting values. तो यहाँ पर what I am doing ना, अच्छा एक चीज I have missed from here. So this will be ai aj. I have written this because मैं ai और aj को 1 assume कर रही हूँ. Otherwise, there will be AIs and AJs also. ठीक है. अच्छा, let's start putting values बच्चे. So, बेटा, if I go ahead and I put 1 से शुरू करते हैं, हाँ? तो अगर मैंने I को भी 1 रखा और J को भी 1 रखा, I am putting both I and J as 1. मैंने दोनों को ही 1 रखा है. Then what will happen in this case? बेटा, you can go ahead and you can notice कि यहाँ पे आपके पास आ जाएगा A1, I भी 1 है और J भी 1 है. A1, I भी 1 है और J भी 1 है. प्लस अब मैं I को 1 रख सकती हूँ और J को 2 रख सकती हूँ. तो I 1 है और J 2 है. कोवेरियंस ऑफ x1 x2 प्लस. बेटा अब हम रिवर्स भी कर सकते हैं. I 2 हो सकता है और J 1 हो सकता है. तो कोवेरियंस ऑफ x2 x1 a2 a1 और फिर I और J दोनों 2 हो सकते हैं. प्लस a2 a2 कोवेरियंस ऑफ x2 x2. ऐसे ही चलता रहेगा ये. यू विल डू इट फॉर अदर केसेस ऑल्सो. ये तो मैंने सिर्फ 1 और 2 का कॉम्बिनेशन बनाया है कि अगर I1 हो और J1 हो, I1 J2 J1 I2 एंड J2 I also 2. ऐसे करके मैंने 4 कॉम्बिनेशन बनाए सिर्फ 1 एंड 2 में. मतलब अगर मेरे पास सिर्फ 2 ऑब्जर्वेशन है x1 एंड x2 तो ये ऐसा बनता है. अच्छा, नाउ व्हाट यू नीड टू अंडरस्टैंड बेटा कि whenever we find covariance of something with itself, अगर हम किसी का covariance उसी के साथ ही निकाल रहे हैं, as in covariance of x1 with itself, covariance of x2 with itself, तो जब भी हम किसी चीज का covariance उसी के साथ निकालते हैं, then covariance of a variable with itself, बच्चे, that is called as variance of that variable. तो ये हो जाएगा a1 square variance of x1 प्लस, देखो ये भी a1 a2 है, ये भी a1 a2 है. कोवेरियंस x1 और x2 के बीच में निकालो या x2 या x1 के बीच में, इट शुड मीन द सेम थिंग बिकॉज कोवेरियंस बिटवीन टू वेरिएबल्स क्या हो जाता है बच्चे? समेशन x माइनस x बार, राइट, y माइनस y बार by n, right? Isn't it? Isn't it? So we can go ahead and understand कि हम बेशक ही ये लिखें या हम रिवर्स कर दे, कोवेरियंस y x कर दे. दिस विल बी समेशन y माइनस y बार x minus x bar by n, तो both things are same only ना, दोनों सेम ही तो आ रही हैं यहाँ पे। तो अगर दोनों चीजें सेम ही आ रही हैं तो ये कोवेरियंस x2 और x1 का निकालो, या x1 x2 का, इट शुड मीन द सेम थिंग। तो बेटा isn't this and this combined together, ये हो जाएगा 2a1 a2 कोवेरियंस ऑफ x1 x2। फिर यहां देखो दिस इज a2 स्क्वायर, तो प्लस a2 स्क्वायर। और व्हेन यू फाइंड द कोवेरियंस ऑफ अ वेरिएबल विद इटसेल्फ, जब आप एक वेरिएबल को कोवेरियंस उसी के साथ निकाल रहे हो, देन दैट इज गोइंग टू बी द वेरियंस ऑफ दैट वेरिएबल। तो ये हो जाएगा वेरियंस ऑफ x2। इसी बेसिस पे वी हैव टेकन आउट दिस फॉर्मूला दैट हैज बीन रिटन हियर। तो जब भी हमें x1 एंड x2 के लीनियर कॉम्बिनेशन का वेरिएंस निकालना है, बट दे आर नॉट इंडिपेंडेंट ऑफ ईच अदर, तो हमारा फॉर्मूला ये बन जाए, राइट। तो बेटा ध्यान से देखते हैं, हम एक एग्जाम्पल ले लेते हैं। एग्जाम्पल, अब मैं बोल रही हूं दैट x1 एंड x2 आर डिपेंडेंट वेरिएबल्स। अब वो डिपेंडेंट है, इंडिपेंडेंट नहीं है। और मैं आपको बोल रही हूँ कि y इज इक्वल टू 4x1 प्लस 2x2। और मैं आपको बोलती हूँ फाइंड बेटा द वेरिएंस ऑफ y, y का वेरिएंस निकालो। तो बेटा वेरिएंस ऑफ y क्या हो जाएगा, वेरिएंस ऑफ 4x1 प्लस 2x2। एंड व्हाट इज द फॉर्मूला वी हैव स्टडीड, क्या फॉर्मूला पढ़ा हमने, द फॉर्मूला ऑफ वेरिएंस ऑफ y विल बी a1 square variance of x1 plus a2 square variance of x2 plus 2 a1 a2 कोवेरियंस बिटवीन x1 एंड x2। कोवेरियंस बताता है कि x1 और x2 एक दूसरे के साथ कितना रिलेटेड हैं। तो बेटा दिस इज गोइंग टू बी a1 4 है, 4 का स्क्वायर हो गया 16 वेरिएंस ऑफ x1, a2 है 2, 2 का स्क्वायर विल बी 4 वेरिएंस ऑफ x2 प्लस 4 इंटू 2 8 इंटू 2 दैट मीन 16, यहाँ पे 4 डालो, यहाँ 2 डालो, सो 16 कोवेरियंस ऑफ x1 x2। दिस विल बी द वेरिएंस ऑफ y। अब एग्जाम में ना यू विल बी गिवन वैल्यूज, आपको ऐसा दिया होगा कि वेरिएंस ऑफ x है 2, वेरिएंस ऑफ x2 है 1, कोवेरियंस बिटवीन x1 x2 है हाफ, ऐसा कोई वैल्यूज दी होंगी। यू कैन प्लग दीज वैल्यूज, इसको यहां डालो, इसको यहां लगाओ एंड गेट द आंसर, राइट। तो व्हेन x1 एंड x2 आर नॉट डिपेंडेंट ऑफ ईच अदर, तब आपका फॉर्मूला ये हो जाएगा। ओके, वी हैव डिस्कस्ड दिस आल्सो बेटा। तो variance between x1 minus x2 and x1 plus x2 is the same when they are independent of each other. अच्छा, what if they are dependent? Suppose मैं बोलती हूँ, क्वेश्चन आपको एग्जाम में आ रहा है, the question is that x1 and x2 are dependent. तो can you say that variance of x1 plus x2 will be equal to variance of x1 minus x2? यहां दिया हुआ है कि x1 एंड x2 आर डिपेंडेंट ऑफ ईच अदर, वो एक दूसरे पे डिपेंड करते हैं। तो क्या ऐसा होगा कि वेरिएंस x1 प्लस x2 विल बी इक्वल टू वेरिएंस x1 माइनस x2? लेट्स ट्राई दिस आउट। तो बेटा व्हाट विल बी फॉर्मूला ऑफ दिस, a1 स्क्वायर वेरिएंस ऑफ x1 प्लस a2 स्क्वायर वेरिएंस ऑफ x2 प्लस 2a1 a2 कोवेरियंस बिटवीन x1 x2। So this will turn out to be variance of x1 plus variance of x2 plus 2 covariance x1 x2. बेटा what will be the formula of this? इसका क्या फॉर्मूला होगा, a1 square variance of x1 plus a2 square variance of x2 plus 2 a1 a2 covariance of x1 x2, राइट बेटा। तो अगर हम इसको देखें तो क्या आंसर आ रहा है, वेरिएंस ऑफ x1 प्लस वेरिएंस ऑफ x2 माइनस 2 कोवेरियंस ऑफ x1 x2। तो आर दीज टू थिंग्स द सेम, क्या ये दोनों चीजें बराबर की है? नहीं, एक में वी आर एडिंग एंड एक में वी आर सब्ट्रैक्टिंग। हाँ, व्हेन x1 एंड x2 आर इंडिपेंडेंट ऑफ ईच अदर, अगर ये दोनों एक दूसरे से इंडिपेंडेंट हो जाएं, तो उस केस में कोवेरियंस x1 x2 का 0 हो जाएगा, उनके बीच में कोई रिलेशन ही नहीं रहेगा। सो इफ दे आर इंडिपेंडेंट ऑफ ईच अदर तब बराबर है कि ये वाला भी जीरो और ये वाला भी जीरो है, एंड यू विल बी लेफ्ट अप विद वेरिएंस ऑफ x1 प्लस x2, वेरिएंस ऑफ x1 प्लस x2, तब ठीक है। बट इफ दे आर डिपेंडेंट ऑफ ईच अदर, अगर वो एक दूसरे पे डिपेंडेंट हैं तब नहीं हो सकता, देन बोथ ऑफ देम विल बी डिफरेंट। एम आई क्लियर विद इट? ठीक है बेटा, आगे पढ़ते हैं। ये एग्जाम्पल नंबर 5.29 है आपकी बुक का, तो एग्जाम्पल पढ़ने की कोशिश करो। यहाँ पे आपको दिया हुआ है कि आपके पास एक वेरिएबल है y, और y डिफाइन कर रहा है कि कितना रेवेन्यू एक फर्म अर्न कर रहा है, सपोज। हाँ, और ये जो y वेरिएबल है, दिस इज गिवन टू यू एज 3x1 प्लस 3.2x2 प्लस 3.4x3। और यहाँ पे ये जो x1, x2, x3 है, ये आपको दिया हुआ है कि रेगुलर, एक्स्ट्रा एंड सुपर प्रोडक्ट कुछ होगा, उसमें आपका क्या रेवेन्यू वेटेज रहता है, रेवेन्यू रहता है। तो देखो 3 पर यूनिट है तो 3 यहाँ पे रहा, इसका रेवेन्यू 3.2 पर यूनिट है तो 3.2 ये रहा, और इसका रेवेन्यू 3.4 पर यूनिट है बच्चे, 3.4 ये रहा। तो जो टोटल रेवेन्यू हो गया वो हो गया 3, एक यूनिट पे हम 3 रुपीज अर्न कर रहे हैं, इंटू नंबर ऑफ यूनिट सोल्ड, प्लस 3.2 इंटू नंबर ऑफ यूनिट सोल्ड, प्लस 3.4 इंटू नंबर ऑफ यूनिट्स सोल्ड। ये हमारा यहां से आ गया। अब ये बोल रहा है फाइंड द एवरेज रेवेन्यू अर्नड। तो बच्चे बहुत सिंपल है, इफ आई वांट टू आस्क कि एवरेज रेवेन्यू हम कितना अर्न कर रहे हैं, दिस इज गोइंग टू बी द एक्सपेक्टेड वैल्यू ऑफ 3x1 प्लस 3.2x2 प्लस 3.4x3 प्लस 3.4x3, ये हो गया, राइट बेटा। तो इसको क्या कर सकते हैं, वी नो दिस एक्सपेक्टेड वैल्यू ऑफ ax1 प्लस a1x1 प्लस a2x2 प्लस a3x3 क्या हो जाएगा 3, एक्सपेक्टेड वैल्यू ऑफ x1 प्लस 3.2 एक्सपेक्टेड वैल्यू ऑफ x2 प्लस 3.4 एक्सपेक्टेड वैल्यू ऑफ x3, और ये हो जाएगा 3 μ1 प्लस 3.2 μ2 प्लस 3.4 μ3। बेटा वी ऑलरेडी नो μ1 μ2 μ3 यहाँ दिया हुआ है, μ1 is 1000, μ2 is 500 and μ3 is 300। Put the value। तो instead of μ1 मैंने यहाँ पे 1000 लिखा है, instead of μ2 I have plugged 500, instead of μ3 300, और आंसर आ जाएगा 5620। अब ये बोल रहा है कि रेवेन्यू अर्न्ड इज इंडिपेंडेंट। अब मैं एक प्रोडक्ट कितना बेचती हूँ और दूसरा कितना, वो दोनों एक दूसरे से इंडिपेंडेंट चीजें हैं। सो फाइंड द वेरिएंस ऑफ y का वेरिएंस निकालना है। तो अगेन इट इज वेरी सिंपल बच्चे, व्हाट इज गोइंग टू बी द वेरिएंस ऑफ y, क्या हो जाएगा वेरिएंस ऑफ y? सो वेरिएंस ऑफ y विल बी a1 स्क्वायर, वेरिएंस ऑफ x1 a2 स्क्वायर, वेरिएंस ऑफ x2 a3 स्क्वायर, वेरिएंस ऑफ x3। अब वेरिएंस का वैल्यूज हमें नहीं दिया हुआ है, वी आर एक्चुअली गिवन द स्टैंडर्ड डिविएशन ऑफ x1 x2 एंड x3, तो वेरिएंस निकाल सकते हैं। तो ये हो जाएगा वेरिएंस विल बी 100 स्क्वायर, 80 स्क्वायर, 50 स्क्वायर। ठीक है जी, पुट दिस वेरिएंस हियर, इस वेरिएंस को हम यहां डाल देंगे, पुट दिस वेरिएंस हियर and put this variance here, and when you will be putting these values beta, तो मैं आपको बस यहाँ पे आंसर बता रही हूँ, this would be the answer to this question। अब अगर वो बोलते हैं फाइंड स्टैंडर्ड डिविएशन, तो इसका अंडर रूट निकाल दो एंड यू विल गेट द आंसर टू दिस क्वेश्चन। ओके बेटा, दिस इज द नेक्स्ट क्वेश्चन। देखो ध्यान से, यहाँ पर आपको दिया हुआ है कि μ1 is given to you as 22 and μ2 26, sigma 1 is given to you as 1.2 and sigma 2 1.5। अब क्वेश्चन बोल रहा है फाइंड द एक्सपेक्टेड वैल्यू ऑफ y, और y कैसे डिफाइंड है, y इज डिफाइंड एज x1 माइनस x2। तो अगर मुझे यहां से एक्सपेक्टेड वैल्यू ऑफ y निकालना है, सो दिस इज गोइंग टू बी एक्सपेक्टेड वैल्यू ऑफ x1 माइनस x2। तो बच्चे दिस विल बी एक्सपेक्टेड वैल्यू ऑफ x1 माइनस एक्सपेक्टेड वैल्यू ऑफ x2। तो x1 का एक्सपेक्टेड वैल्यू इज गिवन टू यू एज 22 एंड x2 का 26, सो आई विल पुट 22 माइनस 26, दैट मींस माइनस। ये हमारा फर्स्ट आंसर आ गया। नाउ इट इज आस्किंग फाइंड वेरिएंस ऑफ x1 माइनस x2। तो बेटा इसमें कुछ गलत नहीं करना है एग्जाम में, यू हैव टू बी वेरी वेरी क्लियर विद इट। यहां बोल रहा है फाइंड वेरिएंस ऑफ x1 माइनस x2, तो बेटा वेरिएंस ऑफ क्या हो जाएगा, यहाँ पे आई विल पुट 1 and 1, सो a1 स्क्वायर वेरिएंस ऑफ x1 plus a2 square variance of x2. Beta, this will be variance of x1 plus variance of x2. यहाँ कोई भी बच्चा नेगेटिव साइन नहीं लगाएगा. This will be plus variance of x2. So you can just put the value. तो आपको यहाँ पे standard deviation given है. So variance of x1 will be 1.2 square and variance of x2 will be 1.5 square. So if I just put 1.2 square and 1.5 square, this will be my answer. और यहाँ से आप standard deviation निकाल लो, it will be 1.92. Okay बेटा. अब ये एक proposition है जो मैं highlight करना चाहती हूँ. So मैंने आपको बोला कि suppose these x's are normally distributed. ये जो हमारे x's हैं ये random variable हैं and they are normally distributed. तो बेटा proposition बोलती है कि if y is a linear combination of x's और ये x's normally distributed हैं तो y भी normally distributed होगा. If y is a linear combination of x's are normally distributed, then y will also be normally distributed. Y भी normally distributed होगा. Am I making sense? So if x's are independent and normally distributed, and y is a linear combination of x's, then that will also be normally distributed. Beta, what is its implication? Its implication is that आप y पे z distribution use करके you can find the corresponding probabilities. आप corresponding probability निकाल सकते हो. Let me give you an example of that. उसका एक example लेने की कोशिश करते हैं. So ये अभी हमारा पुराना example ही है. So if you remember, अभी हमने y को ऐसे लिखा था 3x1 plus 3.2x2 plus 3.4x3. Suppose in exam they ask you a question कि what is the probability that average revenue earned by firm exceeds 4500. क्या प्रोबेबिलिटी है कि जो फर्म का रेवेन्यू है वो 4500 को एक्सीड कर रहा है, मतलब y का जो वैल्यू है इट एक्सीड्स 4500. एंड आई एम टेलिंग यू कि जो भी हमारे x1, x2 एंड x3 हैं these are normally distributed. हमने एज्यूम किया है कि ये normally distributed है. So beta, if x1, x2, x3 are normally distributed, so their linear combination will also be normally distributed. जो उनका linear combination आएगा, that will also be normally distributed. तो इनका linear combination क्या बनता है? वही तो y है. So we are assuming that y is also normally distributed. अगर y normally distributed है, if it is normally distributed, I can convert this in standard normal variable format. Isn't it? मैं इसको standard normal variable में convert कर सकती हूँ. So if I try to convert this in standard normal variable format, what will I get? Probability of y minus its mean divided by its standard deviation greater than 4500 minus mean of y divided by standard deviation. Isn't it? And we know बच्चे that this is nothing but z. यही तो z था. Wasn't this z? So I can go ahead and say that this will be probability z greater than, बेटा ये mean हमने calculate किया था. This is 4500 minus क्या mean निकाला था हमने? What was the mean we calculated? 5620. So minus 5620. और क्या standard deviation निकाला था हमने? What was the standard deviation we had calculated? 429.46. So upon 429.46. So when you will solve this, आपको यहाँ मिल जाएगा probability z greater than minus 2.61. So if I have to plot this बच्चे, तो यहाँ पे है 0 because it's a standard normal variable. ये है minus 2.61 and I need to find out this area. So this can be written as 1 minus probability z less than 2.61. And this is nothing but 1 minus till minus 2.61 CDF. ये वाला वैल्यू आपको z के टेबल से मिल जाएगा. You will get this from z table. So you find this out from z table, you put it here and you will be able to get the answer. So when you do that, beta, you will get the answer as 0.9955. So this is a very, very important result, that if x's are normally distributed or if I can apply central limit theorem on x's, then any linear combination of x's will also be normally distributed. Right, beta? So with this, we cover chapter 5. Chapter 5 is over now.